at the different nodal centers. Hope all of you are ready for the classes today. Can I call some of the centers and see you? DIT University? DIT University?
Yes, ma'am. Good morning, ma'am.
Sir, I want to tell you, yesterday also I find very less attendance in your classes. That is not permissible. Okay, DIT University, I require more people to be seen in your classes.
Okay, ma'am.
I watch you. Yesterday also I saw that you are very less in attendance.
Yes, yes, ma'am.
Okay, you tell you who is the coordinator? Gaurav?
Yes, ma'am.
Where is he? Okay, ask him to contact me on phone. I am not happy about it.
Okay.
MM Engineering College, Mulana. MM Engineering College, Mulana.
Yes, ma'am. Good morning, ma'am.
Good morning. Okay, the class is going to start. We are calling an expert from MNIT Jaipur, so the full attendance should be there.
Yeah, sure, ma'am, sure.
Okay, I will be watching, and I want to see that your hall is full. All participants.
Okay, okay, ma'am.
Okay. Okay. MC Saxena, Lucknow. MC Saxena, Lucknow. PVP Siddhartha, Vijayawada.
Yes, ma'am. Good morning, ma'am.
Good morning. Means you are also less in number.
Okay.
Call all your participants.
Okay, they will come in. They are yet to come, ma'am. They will come in 5 minutes.
Okay. 5 minutes is okay.
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 Thank you, ma'am.
Gandhi Academy, Berhampur, Odisha. Gandhi Academy, Berhampur, Odisha. Sri Sukhmani Darabasi. Sri Sukhmani Darabasi.
Good morning, madam.
Good morning. Yes, nice meeting you.
Thank you, ma'am.
Okay, the class is going to start.
Yes, ma'am. The participants are also coming within 5 minutes, ma'am.
Okay, okay, okay. Sri Sukhmani?
Yes, ma'am.
Sukhmani only.
Yeah.
PVP Siddhartha? Gyan? Okay, you people are ready? Thank you. Okay. Welcome to all of you. I am very proud to introduce Dr. Rajesh Kumar. He is here in the morning itself, and he is working as Associate Professor in the Electrical Engineering Department of MNIT, Malviya National Institute of Technology, Jaipur. He is working there for the past 25 years in the Electrical Engineering Department. His areas where he is working is mainly in genetic algorithm and various swarm optimization techniques. So he will be engaging the whole day today, 3 sessions, bio-inspired optimization and swarm optimization techniques. So all of you should take full advantage of his availability, his presence here. He will be explaining you MATLAB, how you implement it in MATLAB, also GA and optimization. So I request all of you to be attentive in the classes, because see, experts you will not. I am available for you every day here, but experts are not available every day. So you take advantage of the experts when they come. That's why I am very particular about it. So sir will be here. He will take the class very leisurely. You can ask him questions. The session should be interactive. Get maximum advantage of his expertise and his knowledge. Over to sir. Sir, I think I have introduced you less. You can introduce introduce yourself so that they can know about you, sir.
Good morning to everyone. And today we are starting with the genetic algorithms, and I'll try to make genetic algorithm as simple as possible. And I'm sure that after this lecture, you can do some good programming in genetic algorithms. So we'll try to think in a different way that how the algorithm people think about the problem, and then how they convert what is happening around us, what is happening in the nature, to some algorithms. Okay, so I start with a very simple definition. Basically, when we are looking for genetic algorithm, we are looking for maximization and minimization of the problems. So this we have studied in class 10th, that to calculate your maxima or minima, the way is to find out the derivative, basically, or find out the gradient, and the place where the gradient becomes 0, it is either a maxima or a minima, and then we go for a second derivative to confirm whether it's a maxima or minima. So this definition works fine when we works in the calculus side, and we do a lot of engineering with this mathematics. On the same basis, there was one approach which is known as your hill climbing approach. This one is again a calculus based approach. So you can have there is a one peak there, and I want to find out where is that peak. That is basically my objective function. So there, when we are looking over this problem, there are two things there. Hill climbing approach is the simple way that you take a person, blindfold him, and then ask him to move. Okay, you move and find out where is the peak. So what that person will do? He just take one step and observe that he's going up, 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 up. At certain point, he observed that now the surface is uniform, and then next step he found that he's going down the hill. That means that is the peak. You convert it to the mathematical form. Going up, up means he's observing the gradient, basically. He's finding the gradient slope, and slope is 0. And then the slope becomes negative. Slope 0 means that is the peak, basically. So that approach is known as your hill climbing approach, and very commonly used in our engineering purpose. It is a calculus based approach, obviously, but the problem appears like this. Now I have two peaks there. One peak on the left hand side, another is on the right hand side. Now a person who is starting from the left hand side, he'll find he keep on moving and stay. Can I have a pointer? Okay. So a person starting from this side, he keep on finding the slopes and gradient, and then it becomes 0 and stay here. And he says, what is this? He conclude that this is the maxima. Whereas a person who is starting from this end, he keep on moving and he'll say this one is the maxima. Now there is a conflict. So there are two maxima for two different persons. That means the calculus based approach is creating problem now here. Okay, and this one is a bit more realistic. So now this is the problem with the calculus based approach. They totally depend upon the initial conditions from where you are starting. If you are starting from this direction, you reach here. You are starting from this direction, you reach here. That means these are the initial conditions from where you are starting, and that decides what is your maximum. Whereas you move further, your problem where you have multiple maximas are there, and what is the best maxima, or what is the maximum point in these multiple maximas. So now the problem is there, what is my initial point? Things become more and more complex, and these are the realistic pictures, real system. We have certain kind of peaks, so many peaks, and peaks are non-uniform, and likewise your system is noisy and your system is discontinuous. Now if system is discontinuous, then to calculate the derivative and all these things create a lot of problem, and that's why people are attracted towards a different scheme of or different methodology to find out the maxima or minimum, and that attracts them to work on something like nature inspired, bio inspired, or some non-derivative or derivative free algorithms. So we will talk about genetic algorithm, which is a derivative free algorithm. Okay, so this is basically what attracts researchers to move towards that side. I'll show you some of the slides which are taken from the Google, and we'll try to understand what is happening there. I'm not going to the depth of the biology, but some features we take it from there, and then we try to correlate with the mathematics to develop the algorithm. Okay, so this one is the first figure, and yes, this is everybody I think studied in class 10th or class 11th that this one is human body. Human body is made of cells. Cells have a nucleus. In nucleus we have chromosomes, and chromosomes are made of DNAs, and DNA are further made of sugars. So this one is simple composition of the body. So From this figure, let's conclude one thing, that all this representation is representation of DNA. So a DNA represents your body, and that's why these things, and they are unique in nature. That's why people go for DNA test and all these things. So this slide give me one thing in my for my algorithm development, that whole representation of this big picture as this composition of DNA and DNA compositions we understand. So let's conclude from here. Move to the next slide. This one is also a very good slide which give you an idea about few things. That is, there is a father and there is mother. You can see two different colors. Two different colors means one is healthy and another one is carrying some kind of a carrier. He's not having that particular disease, but he's a carrier. Okay, so that means father is also a carrier, and mother is also carrier. They are carrying some kind of a disease, but they are not suffering from that. Now when they mate, they reproduce 4 types of children. 1, 2, 3, 4. That means this one is non-carrier child. This one is perfect healthy. That child is not carrying anything. Half of combination of these two, it's a carrier child. Another half of this and half of this, another carrier child, and both carrier portion, that means that is an affected child. So two parents who are the carriers, they can produce 4 type of children. One is perfect healthy, another one is perfectly totally affected, and 2 children which are carriers. So that is the second thing which we can observe from this picture, that what are the issues, what are the problems which are with the parents, or there are certain features which are carried forward from the parents to the children and likewise. It's simple, like nowadays when you move to a doctor and say, sir, I'm feeling a bit uneasy, I'm having a headache. Before measuring anything else, the straightforward question is, do you have a history of blood pressure in your family? That means something is carrying from your parents to you also. Similarly, in your diabetes, they ask you, okay, what is your family history? So that means these things are carried forward. So from here we conclude that, yeah, in humans we carry the things from the parents to the children to the next generation. So that is the second thing we observe from this picture. Third picture is very important. I've taken it again from the Google. You can see you can have a different kind of things which you carry forward. You see there is a resemblance in the faces, basically. A total resemblance. Parents and children, they can easily identify. I mean, there is a very high level of similarity between them. Okay, these are just to see the different aspects. Oh, sorry. This one is another picture. Both are father and son, basically, and you can see that just watching father, you can find out who's the son, and from the son who's. So there is a high level of similarity. This similarity will help us in developing the algorithms also. Some kind of other similarities are also there. Habit similarities are also there. This will help you in modifying your algorithms. That okay, there is not a similarity in one section, but another kind of similarity is also available. Okay, so this one is just some fun pictures because these carry forward, so that I put it to create a bit of interest what is happening in nature and to us and how the things, because this thing next generation is adopting very fast. Nowadays children, they are more attracted by electronic gadgets and all this. There are some other factors also, but there are certain kind of genetical factors also with that. Another picture, you can see the parents. There is one is black, another one is white, and you can watch their children. So I think that theory is also good here. They are carriers and their features are cross multiplied. One is perfectly, one is black, another one is white. This one is a bit combination of those two. So that thing is appearing just to understand, or just to give a support to the hypothesis we are working on. Another kind of hybridization. That is one thing. Second thing is mutation, basically. Mutation means there is happening something different, something different. You have seen some parents are they are small, but the children is very tall. Something different is happening there. Okay, so that means what? My DNA, some change in the DNA is occurring. Some change somewhere is occurring. That's why that is happening to the human beings, and we can take that one to our algorithms also, how to do the mutation part. This one is a good mutations. This one is good mutation. Basically, the parents are not so one can say so smart, or they are not so beautiful, but the children is very beautiful. That means it's a positive mutation which is there. This one is also a positive mutation. So mutations can be in positive in nature. Another example, the parents are not of that IQ level, but the IQ of this person is known to everybody. Is having very high IQ. That means his positive mutations are there. There are negative mutations also. Mutation can be positive, it can be negative, but it create a change in the what is happening. You can see these pictures. These are a bit different than the common things which are going on. So this one is a negative mutation. So mutations can be positive, can be negative in humans. So let's have a third thing which help us in the algorithm, that mutation is a process which is there in genetic algorithm. Okay, this one is another kind of mutation. Yeah, we have seen that there are just one small change in the location of sugar, or one miss of oxygen in a sugar in a DNA, finally end up with leukemia, blood cancer kind of things. These are small changes which are negative mutations, negative changes which are occurring in the human bodies. This picture is very interesting. I have taken it just to understand something important from. This one is the same bird basically, but you can observe the figure 1, 2, 3, 4, and there is somewhere change in all the 4 figures. You can see that the peak point, or the shape of the bird is keep on changing with the time. Okay, the reason is simple, because of the availability of the food and the change of the conditions. They are going to adapt basically. They are going to change the things just to survive. So they are adaptive, hence they are surviving. So let's see another thing. A story of eagle is well known to everybody. Eagle rely on the wings and its beak, basically that part only. But what happened at the age of 40? Wings goes weak. This goes so it cannot fly very high. It cannot catch the thing. So what the bird do? Go to a remote place, break its beak, turn all the feathers and all these things, stay for some time, wait for the time, let them reappear. He is having new wings, a sharper beak, and then another it extends its life to another 40 years. So they are adaptive to the nature because of the needs and all these things. Those are things which are certain kind of birds or humans, or they are taking care just to make the things accessible and to survive for a longer period. That means we have to be adaptive for the survival, and those who are not fit to the environment, that things happen to this one. So here the third or fourth thing comes in, that is survival for the fittest. The story of the Darwins, or the finding of Darwins. Those who are fit to the system or fit to the nature, they survive, rest die out. So earlier 2 pictures, they are changing, they are modifying themselves just to survive. Where they are not adaptive to the system, they die out. Basically, they are eliminated from the system. So that's all for a genetic algorithm to build up. We have certain things. We have mutation, we have reproduction, and we have to find out who is fit to the system, that will survive, who is not fit to the system, that will be die out. So let's build up the algorithm. Just to summarize all these things in a few more slides. That is, we try to, or researchers try to mimic the nature right from the beginning, and for optimization algorithms, they try to develop some kind of algorithms which are random search methods. Basically, these are non-traditional optimization algorithm, like genetic algorithm, neural network, swarm, ant colony optimization, simulated annealing, and these are the class of search. All these methods are search based. Search means they keep on searching the things. They are derivative free. There is no derivative or those things are associated. They just search, find the solution, compare, search, find the solution, and likewise. So in that we have 3 search techniques. We have 3 techniques: calculus based, guided random search, and enumerative techniques. And in guided random, We have evolutionary algorithms, and in evolutionary we have genetic. Again, genetic is further divided, can be divided to parallel and sequential, and then they are further divided, centralized and distributed. So basically, a genetic algorithm is an evolutionary algorithm, and it is a search-based technique. So, some small introduction about the history. This evolutionary algorithm was evolved in 1960s, and GA was created by John Holland in mid of 1970s, and then popularized by Goldberg. We have a well-known book published by Goldberg on genetic algorithm. So Goldberg was the person who popularized genetic algorithm, and it based upon Darwin's theory of evolution, because we need to calculate who is fit and who is not fit. So this one is another representation, biological understanding. We have already discussed those pictures, so I am skipping this slide over this one. In humans, we have like 23 pairs, and chromosomes are divided into genes, and genes are coded. Well, these are biological aspects. For a computer engineer or for engineering side, we believe in numbers, 1-0 sequences. We arrange those sequences. I'll show you with the example how to arrange those things in a sequence, and then how we can apply these operators to solve our problem. This one is, I'm not going into this section because this one is more of a biology. This one is prepared for the biological part, but this one is a reproduction. To understand the reproduction part, what is happening here? This one is father and mother. What we do is, at any point, we say this one is a crossover point. Crossover point means the children will be developed at this stage, means some properties above this of one parent is transferred to the children, and some property of mother is transferred after this point is transferred. So when they cross over, so this property of father and this property of mother produce one children, this father, this mother, and this father produce another children. So this one we call it, in algorithm we call it crossover, where we are crossing it. Okay. So, and the second one is mutation. So only two operators which are very commonly used in genetic algorithm. One is crossover and another one is mutation. And Darwin's theory principle is used to evaluate the process. Who are the fit, they survive. Who are not fit, they will die out. Okay, so I'm skipping this. We start with this one. So how to do this? How to develop an algorithm? We know how the things are happening in nature. 3-4 basic things we understand from what we have seen. How to convert it? So that all these things which are there in the nature, they are in phenotype space. We do some kind of encoding. You can use any kind of encoding method. Convert it into genotype space. Genotype space means space represented in terms of zeros and ones, basically. And then we do all kind of processing in genotype space, but the result people cannot understand 0-1, so we have to convert it back. So we do the decoding, and we give the results in the phenotype space. So we have two kind of space. We have real problem, say x is equal to y square minus 2. I want to do maximum and minimum in the range of y is equal to -5 to +5. So they are the numbers basically. So we have to convert these into some kind of binary number or gray number, whatever you want to do. That's your choice. There's no any hard and fast rule for it. Then we do some genetic algorithm processing, and then we convert it back to the real numbers. So this one is basically working in genetic algorithm. So how to represent a human? It is something like this. This one is representation. 23 chromosomes, so we represent in terms of 101, 10, 10, 10. It's a notation basically. It's not exactly but it's notation. We can represent any particular variable now. I'm talking about the optimization. So variable we can represent it like this: 0, 1, 1, 0, 1 combinations, and which can be used further. So how to do this? So I have two numbers. One is 101110001. Another one is 011001110. Now I want to apply a crossover to it. How to do the crossover? So crossover means, I'll show you many crossover schemes. So one crossover scheme is this one. I put at this point that okay, after the first 3 digit, I'll do the crossover. So once I do the crossover here, This one is my crossover point. So first children will be all first 3 digit of first part and the last digits of the second part, and the second children will be the first 3 of the second and the last of the last. So this one is a basically producing children in terms of in your biology from the parents, or in algorithm I have 2 numbers, what will be the next 2 numbers from those 2 numbers. So this one is one way of doing. There is no any hard and fast rule that you follow this kind of crossover. You'll say no, my problem is more complex, I want to implement different kind of crossover scheme. You can apply like this also. Okay, so I'll do crossover first digit, fourth digit, and 6th and 7th digit. You can do that also. But later people do some research and they come out with some informations also, like how to do this, what should be the crossover point, where to do it. We'll discuss on that. So if I go by the second approach, then all red makes one children and all blue makes another children. So from the 2 numbers which are there at the top, we have 2 new numbers which are at the bottom. So this is mathematically we are doing it, and this is similar to what is there in parents to the children. So this one is one process of your genetic algorithm. How to do the mutation? You have this one is one children you have there, and you take any bit of it. Say I'm taking 1 here and just make it 0. That is mutation. You have one sequence with you, you just create change somewhere in the sequence. Okay, you can create a change here, you can create change here, you can create change here, anywhere you can create a change. But there are again some reasoning is there that where to create a change and what is the good way to create a change and why we do that. We'll discuss those 2 things. In genetic algorithm they associate these 2 things with 2 probabilities basically. One is crossover probability and another one is mutation probability. We'll see what the impact of these probability. But this is exactly how the things are happening there. Okay. So now the algorithm is ready. I know the process. First thing, I need a population because I need parents to produce children. So first is initialize population. Second, you evaluate it whether they are in the range or not, or they are fit or not. Then you apply any termination criteria, stopping criteria, and in criteria from there you select the parents, reproduce, perform mutation, evaluate, and keep on doing till your termination criteria is satisfied. This one is simple 3-step algorithm. Okay, so let's again an important aspect, and then I'll show you one example how to do it. Because once we know and we understand how to do it manually, we can write the algorithm in any of the language which is where you are comfortable with. Genetic algorithms are usually applied for maximization problems, and if you have minimization problem, convert it to a maximization problem. There are various ways, duality, analogy, and all these things you can apply. Maximization problem is why we are going for it. It's very simple. When we having a peak, and I'm trying to find out the peak. If I create a disturbance at the near around the peak, the solution jump away from the peak. Basically, if I create some disturbance, it go either this side or this side. So it will give me a unique point. Whereas if it is a valley, then if you disturb it, it come again back to that same point. So many times it's difficult to get a unique point kind of thing. So people they suggested, okay, let's convert a minimization problem to its maximization problem and solve it. So they are using it for solving those problems. Sorry. Like you convert a minimization problem to a maximization problem. There are many methods to convert a lot of theories have been developed in classical mathematics that how to convert a minimization problem to a maximization. Now let's solve one example, and this will give you the indication how easy it is to use or to solve it by using a genetic algorithm. If you don't have any knowledge of calculus, derivatives, and all these things, I want to maximize this function. Okay, function is y to the power 1.3 plus 10 e to the power minus xy plus sine x minus y plus 3 non-linear kind of a problem. I want to find out what is the maximum, where is the maximum. So, and a range is given to me, that is my variables are in the range of 0 to 14 and they are in the range of 0 to 7. So I divide it and find out manually, okay, what is the range. So one range is 0 to 14 and another one range is 0 to 7. So obviously my population which I am going to produce, it should be in this range. I have to find out the solution, that means in this range, that means all my players or all my parents, they should be in this range. So I choose one point randomly, because it's a random based process. Randomly I choose one point, that is 0 and 5. Let's assume that 0 and 5 is a solution to this problem, y to the power 1.3 10 e to the power minus xy, and now this thing. So this one is one population. So first step is, this one is real number, let's convert it into binary form. So 0 is represented by 0 0 0 and 5 I can take 1 0. So this one is one parent, this one is one member of the population. Okay, then I choose another, randomly I choose another point which is 2 7. I check it, 2 7 is in this range or not. 10 0 to 14 and 0 to 7, yes, it is in this range, so it can be a member of that population. Then I again convert it. Yeah, you are correct that it has to be 0 1 0, but I'm not so good, so by mistake I put it 0 0 1. Okay, so let's assume that I have done some mistake also. Okay, so keep this thing in your mind, that yes, we have, or deliberately we have inserted some error in the conversion process. Okay, so similarly I choose another point and another point. So 1 2 3 4 5 6 I take it because they have to be in pair, otherwise what will happen, some odd numbers, then one has to move alone. I mean, so that create a problem, because one is male, another one has to act as a female, so reproduction only that take place. That strategy you can build, that you can keep one free alone, and I'll talk about the variants also. Those things we can do. But to understand the process, let's take 6 members, or 6 out of 6, 3 are male and 3 are female, who are who satisfy our these conditions. They are in the range, and now let's apply genetic algorithm process to find out what is the maximum of that equation. So these are the points, and we can see yes, these points are within our range. So let's move to this table. Let me tell you, you just need an Excel sheet to write down this code, not more than that. You don't need any MATLAB or Java or C or .NET, nothing like that. Excel sheet is sufficient enough to build any genetic algorithm code on it. Okay, so let's take the string. So this is the string which we have developed, and for our understanding, let's write down what are the x and y's. Okay, now going to the algorithm side, find out what is the fitness. We will go on that one, but what is, if I put these values in my function, what it results to. So I put these values, x is equal to 0, y is equal to 5 in that particular function, I'll get value is 21.02. Similarly, I put the next, I'll get another next. These are the value which are obtained by just substituting the value of x and y into the equation. Okay, once we have equation, then we move to the next step. We try to find out the fitness. How to find out then? Let's apply some rule. So we'll say that fitness, we can find out that how much is the share of that particular function in the total share. Okay, so what I'll do, so I put it 21.02 here and sum all the values here. That will end up some value. So this one, this is having this much fraction in whole. Okay, so I just put it here. I'll name it probability. You can name it anything. That's probability is just I put it. It's a one kind of probability, but you can put it anything. Probability is basically randomness, but here we are calculating. Okay. Similarly, I'll take another one, 15.46 divided by all, and I will complete this whole column. So my fourth column is nothing but it represents the share of that particular function value in total. To understand it much, or to understand it in a better way, let's calculate a cumulative probability. So what I'll do, I'll put first as it is, add next to it, add next to it, add next to it, add next to it, and last has to be 1. So if it is coming 1, that means we have calculated the things correctly. And this one is nothing but it is basically, you can say, you can take this one like this. This one is, I don't know, watchable or not. This one is circle whose area is 1, and the share means how much I am taking out. So this one is having high share, this one is in low share, this one is less, then this one is much less. So this one is what we have done in the last part. That is cumulative probability we are calculating. Once this one is ready, then we need to do few more things. Let's check out the fitness probability. So there are certain rules. There are certain rules in different books. One is Routry wheel. Those who are familiar with genetic algorithm, they are using Routry wheel. Another way of doing the same thing is something like this. I have drawn one picture in front of you, and this I think you have seen in fairs or in casinos or something like this, that there is a wheel with the different areas, and there is a pointer, and they rotate the wheel, and where it stops, according to there is some reward or award is there. Okay, this one is very common in casinos or in your fairs and all these things. So here I can say, if this is my wheel, and if I'm a businessman, what I'll do, I'll keep the least price here and maximum price here. Okay, you put 10 rupees for this one. If it appears, I'll give you 10 times, and if this appears, obviously I'll give you only 2 times or one time only, something like that. And there is another reason where you'll get nothing, something like that. The reason is very simple, because the probability of this surface is very high, so less reward, and probability of this one is very less, so high reward. So this one is from the business perspective, but from the fitness perspective, this one is more fit. That's why its probability is very high. So this is how we are doing in life also, but how to do in computer programming. So what I have done here is, I randomly throw one point. I randomly take any number. Say the number appears 0.269 in the range of 0 to 1. So 0.269 is near to this value. So I repeat this string here. That means this one is fit. Then I again throw another point. Randomly I am selecting these points in the range of 0 to 1. The second point is 0.923. So I put this string here. Third throw, fourth throw, fifth throw, and again sixth throw. Just to find out who is fit and who is not fit. That's either you do by throwing random numbers, because you cannot create like such kind of structure, because it's difficult to create such kind of structures, those who are newcomers to computer programming. Instead of that, what I'm doing is I'm just randomly I'm picking some numbers, and the number is near to which probability, that string I repeat. Now if you compare the last string with the first, something is repeated and something is eliminated. Can we have from there? This is repeated here. This is repeated. If this is repeated here, something is eliminated. Huh? This one is eliminated. Okay. Check their fitness. This one is having least fitness. That's why this one is out of the scene. This one is having maximum. So this one is repeated. Now you can say that you are doing it manually and that's why you are getting it. You do it. It comes because random process, when you check those things, it will come naturally. It comes naturally because of this wheel rule also. Those who are least in area, when you move it times, you'll find that they are eliminated. Otherwise, ये business बंद हो जाता. But still, it is going on because there are very less chances that people will every time they hit this target. So now this is the string which is a string which is fit string, and it will play further. Now these are the, or you can say biology, you can say these are the parents who are medically fit. Okay, we are building some kind of population which is fit and healthy, so they go further. So this string comes here, and then we apply the crossover, because now these are the parents, and from here we have to develop the children basically. So for that we go for a crossover. So for a crossover, I apply some kind of a rule now. This is my rule, you can have your own rule. We will discuss those issues also. And the rule is like this, that again I'll throw probability. I calculate random number. If my random number comes in this range, then I'll do crossover here. If the random number comes here in this range, crossover here, likewise. Okay, so I'll take these two parents, get a number that is 0.707. So I'll do the crossover here. So there are two children from here, 0, 0, 0, 1, 1, 0, and 1, 0, 0, 1, 0, 1. Again, I'll take another random number, 0.505. It appears here. Okay, so I'll take 0, 0, 0, 1, 1, 1, and 1, 0, 0, 1, 1, 0, 1. Again, I'll take another random number. It appears here, and you can have it. In this case, you have different crossover points. You can have fixed crossover points also. It's your choice. You can have multiple crossover points also. That is again your choice. This is one example I am showing that yes, we have different crossover points. So now crossover is done. This one, now children are there. Then only the last thing left, that is mutation we have to do. How to do the mutation? Mutation is basically what I'll do is I'll move this box throughout these strings like this, and at the same time I'll keep on finding the probabilities, random number generation. Anywhere where your probability random number is greater than 0.95, I'll change that bit. Or otherwise I'll leave that bit as it is. You got the point? Okay, I'll move this box, put this box here, find out the random number. If it is more than 0.95, I change this 0 to 1. Otherwise, leave it as it is. Then move forward, and I move throughout whole this process. Okay, so when I do this, I'll find that there are only 3 points where the probability appears more than 0.95, and then I change these bits like this. Now whole process is over. Genetic algorithm is over. What I have to do? I have to repeat whole process. So now this string, I put it here. Okay, go to iteration 2. So I'll take this one, put it here, find out x and y, find out all function values, and keep on repeating this process. If you compare this fx and y function values and previous function values, you can have two things. Previous average was 12.71. New average is 15.52. That means we are going in a correct direction. We have to find out the maximum. So whole average is increasing. That means we are moving to the maximum. Previous maximum was 21.02. New maxima is 25.43. You do 1000 iterations, you'll find that you reach to the maximum something. And that's all about the genetic algorithm in total. It's such a simple process. No mathematics. Mathematics I need only of the class of somewhere around 10th class mathematics. If I know, I can work on this. Okay. This figure is nothing but some results, some examples, and then some parameters. How to choose those parameters, and what are the issues, what are the benefits. Let's discuss on those points. This one is a well-known problem of TSP problem. That is travelsman salesman's problem. Okay, so the person has to visit all the cities, and he has limited resources. So the target is how he has to visit all the cities. That's objective, but with the minimum distance to cover, so that he can save some kind of a petrol or something. So the minimum distance problem, basically, it's a minimum distance problem. With constraint, he has to visit all the cities. So the question is where to start and what is the next city to go, and likewise. So it's a standard problem. There's nothing like a derivative. People have converted this problem to calculus problem and they try to solve it. But you can apply it to genetic algorithm. Initially, the distance was 941, but after some 800 iterations, a few iterations, distance comes around 800. Then it reduces to 652, and then finally it end up with a performance result of 420. That is basically the distance. So it keep on modifying after every iteration. So this one is basically a simple example of travel salesman problem which people have done. What are the benefits of this one? Let's have discuss over it. I think you agree on the first part. That is, the concept is very easy to understand. Only 3 things you have to do, and just your algorithm does it. So concept is not a very complex concept. No typical biology, just surfacial biology information is required. This one is very important. Modular and separate from application. Your genetic algorithm is problem dependent free. You develop it today, use it throughout your life. Whether it's is there any query from there? Okay. You develop it today, and then you can use it to electrical engineering, electronic engineering, bioinformatics, any area. The same problem can be implemented because it take the inputs in terms of number, solve, give the output. So it's a application free. It's modular. You can.
Hello. Excuse me, sir.
Yes, please.
सर जो आपकी लास्ट पीपीटी थी मतलब हाउ टू अप्लाई जीए, उसमें जो था आपका लास्ट हाउ टू गेट स्ट्रिंग, लास्ट स्ट्रिंग, दैट इज नॉट क्लियर सर आफ्टर क्यूमुलेटिव प्रोबेबिलिटी. I think that is more important. Next. Yes. Yeah. This is the last string.
This one?
After cumulative probability, there is how to get this string.
Here.
6th column. Yeah.
This one?
6th column. Yeah. Yes, sir.
So I have to go back, huh? Okay.
Yes, sir. Sorry, sir.
It's okay. It's okay. Not a big job. Yeah, simple. Just I take any random number. Okay, with range of 0 to 1. Fine.
Okay.
So the random number is say 0.269. So 0.269 is near to which number? Somewhere here.
Yes.
Okay. So I put it this string here as it is.
Okay, sir.
Okay, then I take another number, that is 0.923. 0.923 is near to this one, so I put this one here. Okay, again I throw 0.117, so it is near to this, I put it again here, and likewise I complete this process.
Okay, sir.
Is it okay?
Yes, sir.
Okay, fine.
Thank you.
Okay. So
Thank you.
we move forward to that section. This one is modular basically. You create a separate module for crossover.
Excuse me, sir.
Yes, please.
Sir, mutation part is not clear. Again, please, if you please explain that. Mutation parts only.
Okay.
Yes,
Yeah.
sir. This one.
So what we have done here is I just take this box and put it on all the numbers, all the digits here, one by one. Okay, so I put it here and just get one random number. If the random number is more than 0.95, I create a change. Otherwise, I leave that thing as it is. And I move this box here, or all these digits. Is that okay? Yes. Digits change. If it is 0, you make it 1. If it is 1, you make it 0.
Hello, sir.
Hello, sir.
If we have to change, we have to change, and that we have to change only in case if your probability is any more than 0.9. Only this. हाँ, वो उसके ऊपर आ रहा हूँ मैं भी, वहाँ तक पहुँचा नहीं. Variables, दो ही variables, there are only two variables. आपने एक एल्गोरिथम में सिंपली बना के फर्स्ट डिजिट रैंडम नंबर लिया, and if random number is 0.95, I change it. Then next digit, if it is not, leave it. Next, leave it. It's simple process. One by one we are throwing it. So there are around how many things? 1, 2, 3, 4, 5, 6, and there are 6. So 36 times I just find out the random numbers and check it. At what points the probability is more than 0.95, I change those. Rest I keep as it is. Yeah, randomly. There are other ways also. This one is one way which I have taken. Yeah. Any another query on this part?
Sir, good morning.
Yeah, good morning.
So one more question, sir.
Yes, please.
Sir, this 0.95 was chosen randomly.
Yes, it is chosen randomly.
So in that case, without following the whole procedure, simply I can go and change three or four digits in that string. Without moving this box, I can simply go and change any 3 or 4 digit randomly in that string.
Yeah, that you can do. That you can do. I'm coming to those.
Okay, fine, thanks.
This one is just to understand how the things works. About the variables, let's discuss. Okay. Anything, any question on the working procedure, how we are doing it? Then we'll talk about your choosing these values, parameters, and all these things. Okay. So we are somewhere here, and also on the discussion which is very obvious, that how to choose the probability values and all that. Okay, I'm discussing on the second point, which is modular. Basically, modular means you can design your crossover function separately, design your mutation function separately, and design your evaluation function separately, and you can do anything anytime. There is no any hard and fast rule. Again, I'll say that you have to check first fitness first, then crossover, then mutation. No, I'll do first mutation, then I'll do crossover, then I'll check the fitness. These are modular. You can put these modulars in 3 different computers also. You can do parallel processing also. So the way you want to use, you can use it. That's why people are more attracted. There is no any yeah. Even if you follow particular sequence, and if you solve this problem 100 times, you'll get 100 different results. The reason is this totally depends upon the probabilities, and every time you have different probabilities, you will get a different answer. Then people come out with some kind of a solutions. Basically, solutions, how to check it? They run the same program for some standard norms like 30 times. It is now a benchmark. 30 times. Some people go even higher also. Then in 30 times they report what is the best value, what is the worst value, what is the standard deviation, and that's how they compare the results. Because all these are random based process, you cannot make them, yes, it will give you a perfect value. If it is perfect, then it is not random based. Okay, so then people also mixing your random based with deterministic, also heuristic and deterministic combinations to get a unique solution. That's then again a different story. But how to report is, you run it for 10, earlier it was 10 times, now they are in this recent papers they are going for 30 times, and they report what is the worst value, what is the best value, and what is the standard deviation, like this. Okay, so this one is application free method, and it's a modular. Another good aspect is it supports your multi-objective problems in a very, very good way. Multi-objective of same leading to a same objective, multi-objective which are opposing to each other also. They are opposing. And the common example is everybody wants the luxury of Audi in the range of Maruti basically. So those are opposite objective functions. I want luxury of Audi, but I want to pay the price of Maruti. So both are opposite. So what is the best compromising solutions? So these algorithms works very fine. And then it is good for noisy environment. Noisy environment means the input data are not correct. We have seen deliberately we have inserted somewhere some error, some problem into the system, and when we solve in the iterations, we found that that part will be eliminated. And most of our engineering problems they have noise in their inputs. So this one is very good if your environment is having noise. It always gets better with time. Iterations, near out iterations, more iterations, those things people are working on. Should we start from very fresh, or should we save the old data and apply geo or that one? So there are different combinations people are trying. Then there is a parallelism in it, and they are easily distributed, that we have already discussed. Now coming to the two important points. What should be the crossover probability and what is mutation probability? Well, let's take in terms of a simple string is there, and there are two bits which are there, most significant bit and least significant. Okay. Now if I change the most significant bit, what will happen? Large variation. The child is totally different from the parents, which nobody wants. In mathematical or in computer programming, what that means? I am very much near to the solution, but I create a very large change, so it move away from the solution. It will take a lot of time to reach to the solution. Okay, so I have to be on that side where there is a less change. But if I'm doing no change, then children will be exactly like the parents. So where I'm staying or where I'm stuck up, I have to remain there. I have to come out of it. So that's how you can choose your mutation probability. So more than 0.95 means there are less chances. If I make it very less, you'll find that the next generation is totally different from the previous generation, and the convergence process will be slow. So that's how you can make a choice. Now it varies from problem to problem. More complex problem, then you have to rearrange your mutation probability towards that. Well, that problem needs to come out of there are multiple, like I have a global minima, but there are multiple minima near around. देखिए, ऑप्टिमाइजेशन में चेंज की पॉसिबिलिटी प्रॉब्लम से होती है. मैं आपको वही बताने जा रहा था कि अगर मेरा प्रॉब्लम ऐसा है कि जिसके अंदर ग्लोबल है और उसके पास में लोकल मिनिमा बहुत सारे, तो मेरे को उनसे बाहर निकालना है, तो मैं थोड़ा सा हायर साइड की तरफ जाऊंगा ताकि उनमें से निकले और वो कोई ना कोई ग्लोबल की तरफ जाए. और अगर मेरी प्रॉब्लम ऐसी है कि लोकल के आसपास, ग्लोबल के आसपास मिनिमा जितने ज्यादा नहीं है, तो मैं ज्यादा वेरिएशन की सोचूंगा. कम वेरिएशन की जब सोचूंगा जब मेरे आसपास में ही कहीं सॉल्यूशन. तो मेरे को प्रॉब्लम की अंडरस्टैंडिंग होना बहुत जरूरी है कि मेरी प्रॉब्लम को जिसको मैं सॉल्व करने जा रहा हूँ ऑप्टिमाइजेशन के लिए, उसका नेचर कैसा, वो किस तरीके की प्रॉब्लम. दैट इज मोस्ट इंपॉर्टेंट एंड दैट डिसाइड्स your crossover probability and mutation probability. The basic rule is simple that if I change a bit on the higher side, it will give a very different population, and that is the same on the crossover also. अगर crossover हो रहा है, अगर crossover मैंने बैलेंस नहीं किया, बैलेंस नहीं crossover मैंने नीचे की तरफ किया, तो एग्जैक्ट पेरेंट्स जैसे ही चिल्ड्रन आएंगे. और अगर crossover मैंने हायर साइड में कर दिया तो वो डिफरेंस क्रिएट होते चले. तो इसलिए क्रॉसओवर प्रोबेबिलिटी में हम क्या करते हैं, क्रॉसओवर प्रोबेबिलिटी में हाफ के से नीचे की तरफ रखने की कोशिश करते हैं. म्यूटेशन के अंदर बहुत high probability रखने की कोशिश करते हैं, because mutation means you are very much near to the solution, just you have to create a small change whether there is something near around or that. This one is basically which is important for you to check. In some papers they have written that we have taken this crossover and this mutation probability because that is applicable to that problem. That is not universal, you cannot apply that to other kind of problem. So depending upon problem, you can create a change in your PC and PM. Very common notation. PC crossover probability, PM your mutation probability. Okay, and there are many ways to speed up, and that too depends upon the knowledge of your problem. Speed up में आप कुछ कई सारे काम कर सकते हैं. There's okay. I'll just explain one kind of a philosophy. Basically, the next generation of these algorithms is just philosophical thoughts and mixing those thoughts with this. What I'll do is after first evaluation, after the evaluation of the parents, I have all functions with me. I rank them according to the fitness. Which is having best fitness, I rank them 1, then 2, then 3, then 4, and then 5. And then I do the crossover between the best ranked persons. Got the point? Okay, I'll go back to the slide to make it clear. See, I got this fitness with me, this function. Okay, now instead of putting them like this, what I'll do is I'll put the best fitness here, this value here, next to it, next to it, next to it, and the least one at the bottom. So what I'm doing is I'm doing crossover between the best and the worst. What will happen? Best move faster. It will reach to the solution fast because it is among the best. So that is one way of enhancing your algorithm, and people call it rank-based genetic algorithm. You do the ranking and then do all the process. That is one way of doing rank-based. Another way of doing the same this thing is what I'll do is others. I'm talking about variants. People have done it. Some may not be. What I'll do is I replace the worst by best. जो worst आया उसको kill कर दिया और जो best उसका column बना दिया algorithm. So then I'm going much faster, more faster now, because the solution which is worst, it will create the problem. It will create the problem in the convergence of characteristics. So there can be different variants which you can use for your purpose. Okay, so another important easy to alternate solutions history and range. Yeah, there's a very good history now, more than 5,000 or 8,000 articles you'll find on genetic algorithm in different domains. Okay, this one is very important aspect, when to use genetic algorithm, and nowadays it's becoming a big problem. The reason is you'll find people have some problem, they simply apply genetic algorithm and then submit article for publication, and the reverse first question is there a requirement of GA to this problem or not? Sometimes it is not required, but deliberately just they put some good figures and then just they push it. So where to use it? The first thing is, have you checked alternate solutions? And if they are there, are they very slow or very complicated one? I have a simple linear optimization problem. Why should I apply GA? You apply any linear programming problem solver or any solution to it. There's no need of applying this. So you just check it, that if the solutions and if the methods are very complicated, then we have to go for such kind of algorithms. Okay, problem is similar to one that has been successfully solved using genetic algorithm. This one is very important when we do research. Say I compare two things. One is traffic management in civil engineering. We have certain roads and we have traffic, and then how to divert the thing so that time saving is there. This one is analogous of traffic management in your internet, basically network system. You have traffic on the system, wired system, and how to manage those things. So if somebody has done on the similarly, say they have implemented this thing on the civil engineering problem, then it is good. You can directly jump to the problem if you are working on the traffic management on the wireless network or sensor network something. So you have to check it whether people have implemented on the similar kind of problems or not. If you want to hybridize to get the existing solution better, this one is one way. And last one is not a much benefit of genetic technology meet key problem requirements. This one is just to enhance your solutions. Basically, my problem is complex. Half part or sub part I have done through my genetic algorithm. I know initial solutions, and now I use my calculus based approach. So that those things you can do. Lot of this one. Lot of application: control, design, scheduling, robotics, machine learning, signal processing, game playing, combinatorial optimization. You just name the area it is applicable basically. So this one is fun. Now how to do it in MATLAB? That is one way. This first section I explained if you are interested in building your own algorithm. But there are softwares where these things are inbuilt basically. So how to use it? So if you want to use genetic algorithm in MATLAB, so first thing you have to create a function basically, which you want to maximize or minimize. The way of creating a function is function z is equal to my func, that as name I have given, and z, the equation written there, that is the function which I want to maximize. So maximization is, this one is function creation, and this is the function which I want to maximize. So this one is a two variable problem, x1 square minus 2x1 x2 plus 6x1 plus x2 square minus 6x2. This is a function which I want to maximize or minimize accordingly. Okay, and the function is created. You just save this one in any particular folder, and the way to handler is at the rate of function name. So h is equal to at the rate of my fun, because I have created a function with the name my fun. You can create with your name also, there is no issue with this. So there are two ways to solve it now, genetic algorithm. One way is calling a genetic algorithm function, and another way is you can use your GUI of which is there in MATLAB. Yes, please. Yeah, there are many tools. So I'm just giving you, there are two ways. Either you call the function and solve it, or you go for your GUI interface and you can do it by using. So one way is, if you are interested in function way of doing the things. So xfvar, and that is GA at the rate. Here you write down your function name, NVR, that are the number of the variables, and their option. And if you find out in option, you'll find another big list how you want to use that particular function. So like in previous case, I have developed my fun. So I write here at the rate my fun, number of variables are 2, options I choose the default which is already there. You run it, it will give you the value of x1 and x2, and also give the value of the solution. This is one way of doing it in the MATLAB. Second one is you can use GA tool. Earlier version GA tool, now it is modified. So when you type GA tool, this screen will appear to you. Okay, this screen will appear. So what you have to do is you write down here your function name, number of the variables. If you want to see the graphs, so you can tick what graphs you want to see and press this button. I think it till 11 it works, till 12 it works, still it works, but it not modified version is also available. Okay, so you just put the start button, and when you put the start button, it run and give you a solution. Okay, these things are already there inbuilt. You can play with these things basically. How you want to, what is the fitness function you want to use, what is the mutation, crossover, these values you want to change. You want to see what is the impact of these values for your problem. You can vary these problems. By default, they have all their own settings. But if you are doing a research, then you must check these things also. And these are the various scores or graphs you can what is the, how the best fitness is moving with every iteration, or how the best individual is moving, how the pattern is coming up. All these things will appear on your screen. So how to write it? Function at the rate, function name, variables. It's a 2 variable problem, and then you press the button. It will show GA running. After it stops, It will give you the two variables, so the solution of the two variables, and what is the final value, fitness function. So this one is simple press button kind of system, but what is happening inside here, it's a difficult issue. And if you want to play with the algorithm, you cannot do it here because it's only press button kind of thing. Say you want to make your crossover probability, you want to play with that one. Okay, every iteration it moves in different range so that I'll get a fast convergence. You cannot do it here. For that you have to write down the code. So there are various stopping criteria. You can pause it, you can stop it, or if you're writing your algorithm, then again you can have different stopping criteria. You can say that, okay, after 1000 iterations stop, it will stop. Or you can say that, okay, if your solution is in this range, stop, it will stop. Or you can say that, okay, my solution is repeated twice or thrice, stop, you can stop. So there can be different numbers of stopping criteria. And these things you can do it in your MATLAB. You can go to help file. All these things are explained there in your MATLAB toolbox, where you can fix all these things. You can have different plots: fitness, expectations, score, diversity, stopping, scores, genealogy, range, selection, and all this. So it will give you results and it will give you the solution. Okay. This one is one example. What we have obtained, just to explain you. Many of you are from electrical engineering. This one is induction motor drive control problem. What is the problem? I'm coming directly to the problem. I think you are from electrical. Many of you are here. So this one is basically a drive scheme. We have here induction motor, which is controlled through an inverter, and this controlling of inverter or firing pulses, we are using 1, 2, 3, 4 controllers. So all these 4 controllers are 4 PI controllers. So, and there is a problem in PI controller, and the problem is the tuning of PI controller. That is the biggest issue in PI controllers. So I am using 4 controllers. That means I have to control 8 parameters, 2 PI for each. Okay.
इंडक्शन मोटर चल रही है
anything serious? And just to give you one example, this one is I'm showing that how you can do it basically. There are other ways also. Those not from computer electrical engineering, they may find it means out of the basically their interest. But you just understand, I have an issue to optimize few things by controlling the variables in 4 controllers. And 4 controllers, there are 2 parameters, so total makes 8. And what I'm doing here now, so this one is how I can represent. Okay, first 4 digit for one PI, P, KP, another 4 digit for KI for first controller. So I fix the digits. So I make a whole string. This is how you can make the variables. Like in that case, we have taken a 0, 2. So first 3 digit for 0 and next 3 digit for 2. So this is how you can represent it, a string. Interesting part is here. So my objective function first. Now you can see, and this one is a good problem for those who are working in your drives and all this. Person wants good steady state response. Good steady state response means it reaches to the desired speed at very faster rate and it remains there. So that is one objective. Okay. Second is, I don't want overshoot. Now we know that yes, if you want to reach your steady state very fast, there will be overshoot, but I don't want to overshoot. So what you have to do, you have to reduce the overshoot. You want a very good steady state. So these are the 2 objectives which are a bit opposite in nature. Third objective, I need a very good transient response. Okay. Fourth objective, I don't want any fluctuation in voltages. Okay. Fifth objective, I don't want fluctuations in current. So I'm putting each and everything there, that I don't want this, don't want this. Don't want means minimizing those things. I want to minimize current ripples. I want to minimize voltage ripples. I want to minimize my overshoot. I want to increase my one can say transient response, faster transient. I want to have a good steady state. So 5 I am mixing, and then applied for genetic algorithm. So this one we have tested on a system which is, I don't know where the picture is there. This one is a laboratory where we have implemented your genetic algorithm here through DS PC with the DS1104 controller. We shift it to the inverters and we tested it, and you can see the response. A result I want to show you just to for your just to confirm. Yes, the algorithm works very fine. Desired is this line, and this is what we are getting, both in forward mode and then the reverse mode. It is working very fine. Rotor flux ripples, which are responsible for the currents, and you can see it looks large, but you can see it is 1 and it is 0.005. So they are not very big ripples in there. Similarly, other current ripples, ISQ and ID, because we have divided into DQ frame. So two current ripples, they are very less in nature. And similarly, the other currents on the stator side and rotor side, they are well in the range. So this one is basically just to give indication, and this we tried on online tuning. Offline you can have better result. Online, what's the problem? Because you have to run whole your algorithm within that sample period when you are transmitting your data from your computer to your inverter within that. So we restricted it just for certain iteration. Okay, whatever the results in that iteration we are getting, just you can implement it. But it's not a very good idea to implement a genetic algorithm for online tuning, because every time it will give you a new kind of a solution. So for offline purpose, it's very good. Online, people have developed much more better algorithms which can be. So that's all about some kind of a genetic algorithm, how it works, and how you can use. Yeah, any questions?
In the previous problem, I said that we want to use the transform. So we will have the like more than one fitness function for all the functions individually. We have to apply.
No, you convert all 5 to 1, and there are methods. Alpha 1 F1 plus alpha 2 F2 plus F is like that one, and then you have to play with alpha 1, alpha 2, alpha 3, how they are moving and all these things. So the best you can. Steady state response. Another one is overshoot reduction. Yeah, so these are 5 functions. So 5 functions. So you take alpha 1 F1 plus alpha 2 F2 plus alpha 3 F3, and then you give a weightage to alphas, and like that makes single objective function then. So and then you can apply this one. In many cases, people have two optimal optimization problem, and then Pareto solutions, and then find out the best compromise solutions. So there are a lot of literature on multi-objective genetic algorithm. You check the book by K.M. Deb. It's they have defined how to find out the values of alphas, how to convert your multiple objective to a single objective, and all these things for that.
These sum of functions are for minimization, sum of are for maximization.
Yeah, you can combine them. That's not an issue. That's what I told you, na. I want the luxury of Audi at the price of Maruti. So both are contradictory. One is maximization, luxury maximization, cost minimization. So both are contradictory in nature. So you can combine to one. Yeah.
So मेरे पास एक classifier है जिसके लिए इनको define है और output define है और मैंने इसके define कर लिए 90%. अब मेरे को उसकी जो accuracy वो optimize करनी है अब पूरा 98 तो उसमें क्या क्या बेसिक स्टेप में
देखिए क्लासिफायर के क्लास
ब्लॉक डायग्राम में जो दिए गया ब्लॉक है वो क्लासिफायर की ब्लॉक के कैस्केडेड पैटर्न से
ये क्लासिफायर की प्रॉब्लम है ये उसके अंदर सबसे ये है कि आप कुछ ना कोई मेथड यूज कर रहे होंगे, डिस्टेंस मेथड यूज कर रहे होंगे, सो दैट टू क्लासिफाई देम इन मच बेटर वे, है ना. जो भी मेथड आप यूज कर रहे हैं, डिस्टेंस का है, इक्विवेलेंट डिस्टेंस आपने ले लिया और उसके बेस के ऊपर कर रहे हैं, इंट्रा क्लस्टर डिस्टेंस को मैक्सिमाइज और मिनिमाइज कर रहे हैं, दैट कैन बी वन काइंड ऑफ सॉल्यूशन. नाउ इंट्रा क्लस्टर डिस्टेंस को अगर मेरे को मैक्सिमाइज करना है तो नाउ आई मस्ट हैव दैट इक्वेशन विद मी, और उस इंट्रा क्लस्टर डिस्टेंस की जो इक्वेशन है वो मैं जेनेटिक एल्गोरिथम उस पर इम्प्लीमेंट करूंगा। तो जो मेरे को पैटर्न्स है, पैचेज है, हर एक पॉइंट का पॉइंट टू पॉइंट पैचेज है, वो मेरे को अलग अलग निकाल के दे देगा और एवरेज निकाल के उसको मैक्सिमाइज कर सकता हूँ। इसलिए जो जीए का बॉक्स है, आई नेवर प्रिफर, लेट मी टेल यू, this one MATLAB toolboxes and the inbuilt commands, because you lose the what is happening at the background. Better is you develop these codes yourself. But अगर सिंपल है, जैसे डिस्टेंस का आपने फंक्शन क्रिएट कर लिया, उस फंक्शन को आप वहाँ पे जो फंक्शन का था हैंडलर वहाँ पे डालिए, स्टार्ट बटन दबाइए, आपको रिजल्ट दे देगा। बट रिजल्ट आ जाएगा, बट व्हाट इज हैपनिंग, आई एम स्टिल, आई हैव डाउट ऑन दैट कि पीछे बैकग्राउंड में क्या हुआ, नोबडी knows what is happening. So better you write down it's a simple 4-line or 8-line program that you have to write. You just write down a program in your own way and then try to do it. That is the best way to do all these things.
Then when you do that, it takes lots of iteration, it takes lots of time.
So if the problem is so complex, taking a lot of time, do it distributed computing. Go for parallel computing, put it on 5 machines parallelly. It will give you the results very fast. That we can do. Because here also it will take a lot of time in MATLAB. It is taking a lot of time. Reason is there is another reason there. What it will do, for every iteration, it will search where is that toolbox in whole directory, then take it, then solve it, and through that, so it has to go for whole complete process. That's why it is taking a time. If you are working with Python and C and other codes which directly interact, it will be much faster. That's why MATLAB is a bit slower on the side, because it search in whole directory where is genetic tool and open it, execute it, comes out of it. That is taking a time. But if you are working on some programming language like C or C++ or Python, it works very fast. Yeah, simple programming is much better than, because that is, we have assigned the location, so it directly assess, calculate, and come out of.
Hello.
Yes, please.
Sir, when we write programs for genetic algorithm, data is already given onto which crossover or all the processes to be implemented. Data is already given. Problem, sir, as you told, there is problem is already given on which genetic algorithm will be implemented.
Which genetic? I don't. Can you repeat your question?
Sir, I am asking that before we write program of genetic algorithm,
yes,
data is given of the problem.
Okay.
Is data given, sir? Because when we write the process for crossover, we choose specific data.
There are only 2 variables which you have to choose, PC and PM. That's all. Rest depends upon your problem. And PC and PM you will get through experience. So you start with some kind of some number, some values from your literature survey, that okay, this value is good for your this kind of problem. Start with that one, and then you create some changes in that one for get a better solution.
Okay. Sure. Thanks, sir.
Okay.
Hello.
Yes, please.
There is a question in the problem you selection criteria you use is based on the probability. So, sir, there are other methods means based on the selection criteria. Some other criterias are also there based on which we can select the.
Yes, you can. That's your choice.
So that will be based on means which parameter?
You can say every third digit of my sequence I am going to change. There is no any probability then. It is fixed. If I am having a string of, say, I am a parent string of, say, 10 digits, and I fix it, okay, after every sixth digit I am going to create a crossover, then there is no any probability, that is fixed then.
Okay, then that will not be based on my objective function value.
Objective function is different.
Okay.
This one is operators operate on the values. Basically, what objective functions they use only to calculate how fit they are. That's all. Rest of the thing is independent of objective functions. and that's why once you build it, you can use it for any problem or lifelong.
No, if I means fix that criteria that I am choosing the every sixth or every third, then
Mhm.
will my problem will be converged or not, because it is
That
not based
depends on the problem. That depends on the problem. Your problem is complex, it will never converge.
on, yeah.
And if your problem is simple, it will converge. It can be. So that I cannot comment without seeing the problem.
Okay.
Yes.
Okay, thank you.
Yeah.
Excuse me, sir. Hello.
Morning, sir. Sir, hello.
Normally ज़्यादा population का यह है कि if it is more population, the solution will be slow. It's very obvious. And if it is
Neural network is compulsory that you have more data, you will get a good training and good.
no, in that case also there is a issue. If you have more neurons and then it go for overfitting, and that create a problem. So that is same here also. If the population is very large, then it will take a lot of time to come to the convergence and all that. And if it is very less, then it may stuck up with local minimas. It will never reach to the global one. So that balance depends upon the nature of the problem, because that we have to analyze and we have to create the variations. If my problem, is there any requirement to increase the population in the problem or not, that is very important.
Excuse me, sir.
Yes,
Hello.
please. Yes, please.
When we use a GA tool, if you run a same problem 2 times, 3 times, 4 times, the result used to be entirely different.
Yes, it will be.
To be variation, too much variation in the results. So what is the reason, sir, for
Reason
this?
is because the probabilities. Because of the probabilities, which are 3 probabilities are associated: crossover probability, mutation probability, and probability in your fitness and all that. So if those probabilities are there is a variation, the solution is also different in every cycle.
Okay.
You run it 100
Thank
times,
you.
you will get 100 times different results. Never you will get a same result.
So variation will be should be very less, or it will be entirely different.
Again, I'll say the comment can be done only if the problem is there. In some problems there will be large variation. In some problem it may be less. Some problems have multiple minimas near around. Variation can be
Okay.
large.
Depending on problem.
Yeah, depending on the problem.
Okay, sir. Thank you.
Yeah.
Good morning, sir.
Yes, please.
Actually, we have lost the connection and we haven't seen how to write a function in MATLAB toolbox. GA.
So you please download this presentation from my website. You get it from there. It is there. It is written there in that one.
Okay, sir. Thank you.
Okay, that will help you.
Another question, sir.
Another question.
Yeah, please.
Sir, is there any built-in function which suits our application in GA toolbox, sir?
Building GA toolbox function is already there in MATLAB.
Fitness function, sir.
Fitness function. Fitness is your objective that you have to write. Example is given in the help file. You can use that example to understand it.
Okay, sir. Thank you, sir.
Okay, sir. Thank you, sir.
Yeah. Now your question. देखिए उसमें सिंपल एक there are various ways, but मैं आपको एक simple way करता हूँ. Neural network में you use back propagation. Say okay, that is getting the weights depending on the error, and that is if you are using some method, you are getting the derivatives and all that. With those derivatives, you are modifying your weights. Now what I am doing is weights I make as a variable for my genetic algorithm. Now my algorithm will do the model, and what is your objective? Get the minimization of error, known value, your observed value, the difference is your error. So minimization of error is my objective function. Variables are my weights of the neural network. I apply GA. That GA give me the best weights for my neural network. Next. सबको करेगा ना आप. That depends on you what variables you are taking. I'll take the weights of all the neurons, all the connections, hidden, outer, inner. So all now say 30 weights. So it's a 30-weight problem now. So variables are those, and function is there. So it optimized for objective function, which is minimization of error. If I have that presentation, I can show you if you are interested.
Any more questions? So we can have a tea break now. It's 11:30. More than that. We'll go for a 15 minutes break and again assemble by 11:45. So that you can have more discussions with him. He will go for the rest of his presentations also during that time. So we'll have a 15 minutes of tea break now.
Okay, so I welcome you again, and now this another or also we will discuss on another nature-inspired algorithm that is basically on the swarm, working on the swarms, how the group swarm is group of things they work. And the algorithm is known as particle swarm optimization. So this presentation, these are the key points which we will discuss. A bit introduction on the optimization, what are the procedures you have to follow when you are going for optimization, different algorithms, and different global optimization algorithms, what is particle swarm optimization, how we build up, and some application of PSO on design of the problems. Okay, so this one is again the same slide. I'm using it again and again. The reason is very obvious that earlier people work with gradient based, and now we are working which are gradient free techniques. So optimization is basically we are using in various process. This one is more, I have to speak in the earlier lecture, but let's check these things. Some personal decision making process, because there if somebody asks me how I'm doing it and do some kind of mathematics and find out the derivative and find out the calculations, then I think it is a difficult task for me. But yes, we are doing something like finding the fastest route from home or class, optimal allocation of time for homework, optimal budgeting in the household. Everywhere, every time we are doing some kind of optimization, saving the money and something, all these things. And here what we are doing is rather going to the mathematics or mathematical formulation of these problems. Just by understanding, by experience, by sharing the things, we try to get the best solution. And those aspects we are using to develop some kind of algorithm. And let's see how we can develop some much better algorithm. So global optimization, goal of optimization is to find out the maxima and minima satisfying the constraints. And if the constraints are not there, then it's a feasibility problem. So you have to check it whether I'm looking for a feasibility problem or I'm looking for optimization problem. And in optimization problem, I have one thing which is to be optimized. We call it as objective function. So objective function is what either we want to minimize or we want to maximize. And there are certain examples here which I have put in, that in manufacturing process we want to maximize the profit. In curve fitting or experimental data curve fitting, we want to minimize the deviation of the observed data from the experimental data, prediction data. And the design, it can be a maximize the quality factor or minimize the area if we are working with electronic design and all these things. So we have certain things that minimize the quality factor, maximize the quality factor, minimize the area, minimize the total deviation, maximize the profit. All these are known as the objective functions. And then there are objective function depends upon your some variables. So those are known as the design variables. And the definition is a set of unknowns or variables which affect the value of objective function. So like in manufacturing process, variable may be amount of different resources used, time spent, and likewise. In curve fitting, unknowns are the parameters of the model which has to be calculated. And in design problem, it can be an inductor or geometry layout and likewise. So we have two things which are there in optimization problem. One is objective function which we want to maximize or minimize, and another one is your design variables which helps in getting that objective function. And then there are constraints basically. Constraints means those are the restrictions where we have to work, or they are the limits basically. So in few constraints are there, like if I am designing a resistance, so then there is a constraint that resistance can't be less than 0 or something like, there is nothing like negative resistance. So we have to put some constraints. Okay, find out the solutions, find out the value within these limits. So those are known as your constraints. And there is, if there is nothing objective, no any objective function, just we are looking for some kind of a solution. The user, like it is written there, the user does not particularly want to optimize anything, so that there is no reason to define an objective function. Such problems are known as a feasibility problems. But we are targeting here only for the optimization problems. So we have discussed what are the variables and what are the constraints. So I'm moving a bit fast on this. What we need for optimization? So we need the models and we need the algorithms. And if we are looking for the algorithms, we are looking for three things: how robust they are, how efficient they are, how accurate they are. And these three things helps us in developing new algorithms. so that we will get more robust, efficient, and accurate algorithms. So how the process works basically, this one is a chart. If you are working on any kind of a design problem, follow this one. This one is a very good chart developed by researchers. That is, first check it out, what is the need of optimization, whether it is required in that your problem or not. So if it is yes, then what are your design variables? Sometimes there are dependent variables and there are independent variables. Choose them. What are your design variables? Then formulate the constraints. And if the constraints are ready, then formulate your objective function. This one is if you are working on already existing problem, then it's fine. And if you are looking for try to work on new problem, then yes, you have to formulate a new objective functions. Once first four steps are ready, then check out the bounds, what are the limits of your variables, and then comes the selection of optimization algorithm. So before that, you have 5 steps to complete, and once you have idea about the problem, then select what is your optimization algorithm you are going to use, and then finally you'll come out with some certain kind of a solution. So this one is a flow chart for optimal design procedures. So when you do all these things, your problem look like this. Minimize something subject to constraints. 2 types of constraints are there, very common. One is with equal sign, known as equality constraints, and another one is greater than 0 or less than equal to 0. They are known as inequality constraints. And then people convert these constraints to all equality constraints, and likewise. So there is a different class, but all problems look like this. I want to minimize or maximize something. So minimum of something is your objective function. X1, X2, here are the your decision variables, and subject to, those are the constraints there. So these are this one is constraints, which are, one is inequality constraint, another one is equality constraint. And then we can have bounds also, limits that you cannot vary, you cannot go beyond these limits. So those bounds are just to make the things more realistic, whether these things are possible or not. Otherwise you'll get a solution which is a good solution, but which is not a feasible solution. So you have to put some certain kind of limits of. And then there is another thing that is important, that is what is the classification of the methods. So we can have this one as a classification: single variable problem, multiple variable problem, constraint problem, non-constraint problem, single objective problem, multi-objective problem, linear problem, non-linear problem, and you can add to it hard problems, NP hard, NP soft, P hard, N hard. There is a big classification. So you must understand what is the type of your problem, where it comes in. Depending upon that, you can choose what optimization algorithm you can use. This slide give you a certain idea. Many of persons or researchers who are working, they ask which algorithm is to be used when. So you can check it here. If your objective function is linear, constraints are linear, variables are real, the best algorithm is linear programming. There is no point of jumping to somewhere else. Then similarly, like if you are here, if your constraints are linear, if your objective is linear, variables are binary, then you can use binary integer programming. Similarly, gradient methods are there. So these are some methods, simulated annealing, and there's a big class is there which people have developed while working on different problems, that this algorithm is good. Like here it is written there that genetic algorithm is good for discrete variables. So such kind of upgradation is keep on coming from the researchers through their experience while they work on different kind of a problem. So the important is, while choosing the algorithm, what is the nature of your objective, what is the nature of constraint, and what is the nature of your variables. Depending upon that, you can choose what type of algorithm you have to use. See, linear is there, then you use linear programming methods because they are very fast. Our target of solving any optimization problem is 2. One is the time requirement, and second one is the solution. So if the problem is linear, it will give you a unique solution. Okay, so better solution. Your problem is in the category of non-linear or NP or non-linear hard problem, then you have to use, because you cannot convert those problems to linear problems. Then you can shift to genetic algorithm or swarm optimization or different class of algorithm. Okay. Okay, classification I was skipping. Then two things are very important. One is local minima, another one is global minima. All the research papers you will find these two terms very common. Local minima means near around that one basically. In a very restricted, very small region, if there is a minima existing, that is local minima. And the good methods which are good for local minima, they are gradient based search methods, Newton-Raphson, steepest descent, conjugate gradient, Levenberg-Marquardt algorithm. All these are derivative based methods, and these methods give you a good local solutions. They are not used for a global methods, and the reasons for that one is why they are not good for global. Shortcomings are there. They require the initial point to start. Convergence again depend upon the initial guess, and they stuck up with the local solutions. And the algorithm efficient in solving one problem may not be efficient for another kind of problem, and they can be used only for a narrow range. So that's why they are only good for local solutions, local optima solutions. So if your problem is having only one optima, then you can go for these methods. If your problem is having multiple optimas, then you have to switch over from local to global. Global optimizer means it can in a complete space what is the best solution. So in a complete space we can have many local, but there is only one global. And the algorithms which are used for global, some of them are like simulated annealing, genetic algorithm, ant colony, geometric programming, particle swarm, and there is a very big list which can be used for to get the global optimal solutions. So that you can get it from here. From this figure you can get a good idea. This one is a local, and where this one is a global. So if I'm restricting my search, or I'm trying to find out the best solution only in this region from here to here, then I apply a derivative based method and I'll get a local solution. But if I'm looking for a global solution, then I have to go for these methods, because derivative method can give this one also as a solution and this one also as a solution, depending upon from where they are starting. So that is the meaning of a local and global. So for local, derivative based methods are good. For global, they fail to find out the good solution, and hence we have to move for your nature inspired algorithms. So one kind of a nature inspired algorithm is particle swarm optimization. Basically, swarm means a group, maybe a group of fishes, maybe a group of birds, and any member of it is a particle. So that's why the algorithms comes as a particle swarm optimization. And this one is invented by Russell Aberhart and James Kennedy. Both are electrical engineer, and they coined this algorithm that is known as particle swarm. This works on the behavior, basically works mainly on the behavior of the group members, how the group members are behaving. Very interesting algorithm, which not only shows the impact of the group behavior, but also how they think, how they react, how they interact. So it's a combination of philosophy, working behavior, human behavior, and psychology, all merged together to develop this algorithm. Let's understand how it works. Only this slide will give you the answer how this algorithm will work. Okay, this one is a golden fish problem. So there is a fish somewhere in a pond, okay, and we have to find out the fish. So how to do it? So the way is one person start from this end, another person start from this end. They just search that fish is there or not. Once they do the search, they inform each other. This person says no, there is no any fish here. This person again repeated, no, there is no any fish here. Then they move forward. Then again they search. This person says no fish. That person says yes, fish is here. This person also moves there. And that's all about particle swarm optimization. Nothing more than that. So it depends upon group. So what they are doing basically, every individual is searching, and every individual is sharing the things. So based upon this one, they develop an algorithm, and that is known as particle swarm optimization. So let's understand this algorithm, and then we'll see how good it is. Okay. So what is there now? What is there? We understand it taking example of ourselves so that we can understand the algorithm in a nice way. And let's start with the one problem that I missed some gold coin in this room. Okay, and I have certain friends with me and I have to search it. So this is the job which is assigned, and from here we can correlate our algorithms and the mathematics. So what we'll do, what I'll do, I ask my friends to distribute in this room and ask them, okay, you do the search, you search that particular gold coin which I missed somewhere in this room. So what everyone is doing, he's standing somewhere and he's searching near around. So when he's standing somewhere, he's having some position that I'm standing here. Otherwise what will happen, if I don't distribute them randomly, everybody will start from the corner and it will take a lot of time. So I'll ask, okay, randomly, and forget about the engineering or computational aspect. In behavior also, if we are playing a cricket in the ground, we miss a ball somewhere, what we'll do, distribute randomly and start searching independently first. So that is the same thing we are doing here. So when I do a search, what is there in my mind? I'm standing somewhere, so I have certain position. I have to move because I have to search. So when I want to move, I have certain velocity. So I have two things associated with me. One is my position, second velocity, third whether I get that coin or not. That means the solution. So those things are here. Three vectors. One is x vector, that will give you the location. Where are you standing? Okay. There is then the p vector. P vector records the location of the best solution. So I'm searching here, I don't find anything. So this one is recorded. Then I move forward, I search, there is no coin here, recorded. Then I move. Otherwise what will happen, I move back, and it's very obvious, जहाँ मेरे को coin नहीं मिला, मैं वहाँ पे वापस नहीं जाऊँगा, कहीं दूसरी direction में जाऊँगा. So that means I'm recording somewhere in my mind that I already searched in this region. The solution is not there, I have to go for a different region. So there is x vector, there is p vector, and v is the velocity basically. If I don't have velocity, I cannot move. So every agent, and I'm an agent because I'm working in this group of people here. So every agent has three things: x vector, v vector, and p vector. Is that clear? Okay. And then we calculate fitness in terms p fitness, x fitness. I'll explain what is p fitness and x fitness. Let's move forward. So the basic idea is each particle is searching for the optimum, or each particle is searching for the solution. Each particle is moving, otherwise they cannot search, so they have velocity. That is the second thing. Third, each particle remember the position where he has already searched and what was the solution. So three things they are there, but it is not good of its own. They have to help. Otherwise what will happen? We keep on searching, everybody keep on searching. So to increase the speed, what we'll do? I'll search and then I inform my friend, no, there's no coin this side. That he will also tell me. So I'll not go in that direction. Say I'm searching in this corner and my friend is searching in this corner and he says, no, the coin is not in this side. So I'll not go in that side. So what I'm reducing my search space and I can find the solution very fast. So there are four things. Okay. Everybody is searching, they are moving, so velocity, they know where they have searched and they share the information. Okay. So the particles in the swarm, they cooperate each other. Non-cooperative होते हैं, variants हम create कर सकते हैं, उसकी बात करेंगे. But they cooperate each other. The cooperation need only, it has to be simple. So if they cooperate, that means there is a neighborhood associated with them. There is neighborhood, some kind of a neighborhood. They talk to the persons who are neighbor to them, and that will help in getting the solution faster. Okay. The particle knows the fitness. Neighborhood means the person who is next to me. He's informing me that solution is not on this side, don't come. So I use that information to decide in which direction I have to move. Okay, let's understand it this way, and then we write down the mathematical equations. So that means there is neighborhood. So neighborhood can be of different type. Okay. So these are the particles which are thrown to find out the maxima. Okay. So in this search space. So there is one kind of, some particles are thrown the boundary also. I have to search in this room and there is no any boundary, and this one is on say on 10th floor. So what I'll do, I'll assign few person on the boundary of it. Okay, don't allow people to go beyond it, otherwise they will fall down. So you people, those who are boundary, you search on the boundary, rest of people will search inside that. So this is how I created this space. So they move and they search in the directions given.
डोनर मिथुन। अच्छा, इन्हीं इन्हीं का गया था नेट, इन्हीं का गया।
so we are here. Okay, so I put a few of my friends on the boundary and few inside it and ask them, okay, you do the search. So they are doing searching in different directions randomly. Okay, so we are talking about some kind of initialization. This is how I initialize my process. So randomly I put my friends to search that golden coin in the room, and this is how they are distributed. Okay, so the idea we have already discussed this one. Okay, so what a particle does, basically what I am doing by all this process. So each time step a particle has to move to a new position by adjusting its velocity. The adjustment is what we are doing. It's a current velocity plus the weighted random. So mathematics is some points are written, but let's understand it in a simple way. Once I get information from my friends and I have certain velocity, I move from position A to position B. Okay, so and if I'm talking everything in terms of iteration, so velocity is nothing but a position by the iteration time steps, and if my iteration is 1, so velocity is nothing but a position. So this one is my old position, I add a new position, so I move from here to here. This is basically idea how I'm moving, and the direction is decided by the information which I'm receiving from my friends. So let's talk about the neighborhood. One kind of neighborhood is geographical neighborhood, that who is just near to me. Okay, this one is exam neighborhood. Okay, the person who helped me the most is who is sitting in front of me and who is sitting back of me. That is the best person who can help. That is a geographical neighborhood. And we do all these things. Yes, we have done somewhere in life also. So the same things are replaced here. Another is this one is geographical. Another one is social. Okay, so nowadays people are using that one. They save the question papers and answers through WhatsApps and all that. That is social network. So that is also there. Okay, so that is social neighborhood. And third one is basically one can say global neighborhood. Who combine with each and everybody, who is so popular or so connected with everyone. So they are coin is not here, coin is not here. So basically never. So that is global. So then we can make a decision, basically how to decide it. So one decision is basically, this one is known as circular neighborhood decision. We create a virtual circuit. I'll ask who is in front of me, who is back of me. That person asks to me and next person likewise. So person 1 will ask only with 2 and 8, 2 will ask with 1 and 3, 3 will ask 2 and 4, and likewise. This one is one kind of a topology, you can use it for your purpose. Okay, another kind of topology can be a star topology. I'll discuss more on those topologies and all that. So this one is two things we have already done. We randomly distribute, we search, and we some kind of a neighborhood who is neighborhood. But how then I make a decision which direction I have to go? So this one helps me. Say I'm here, and this one is the direction of my movement. Basically, I'm here and I am thinking to go in this direction. Okay, then, but while this one is my orientation, but while going to in that direction, I have certain kind of thinking that in this direction the slope is there. So there is a chances, there is a probability that the coin is in this direction. So this one is my preference, my best preference, which is I am thinking. Whereas my friends who are my neighbor, they are saying no, this one is the direction where there is more probability. So these are the things which make me take a decision. So I am moving in this direction, then I take my preference, my idea. Okay, slope मेरे को उधर की तरफ ज़्यादा slope लग रहा है. Let me go to that side. So I take a turn. Okay, so I take a turn. While moving that direction, my friend shouted that this side there is more probability. I'll move in that direction. So this is how I take a decision of my motion. This is how I move. You just understand the philosophy, then mathematically we can define. So one is I proximity, that is my individual proximity. It's my preferences. Second one is G proximity, that is my friends or my global proximity. What is their decision? And in life we have to work with these. There are my personal preferences in life, and there is a group preferences. Sometimes we have to see the group preferences, sometimes we go for personal preferences, and we'll see that how they affect the algorithm also. So that's all the algorithm. Now let's write down the story in equations, and these are the equations for your particle sum optimization. Only 2 equations and the algorithm is ready. Okay, so I have to calculate the velocity basically to move. So velocity equation is there. Velocity omega into vid t minus 1 initial velocity plus some constant into random number PID my personal best, my preference. XID means where I am right now. C2 another constant function. PGD means my group best. XID means my personal. From here I'll get a velocity. Velocity into time is distance. Time here is 1 because every iteration I'm calculating. So that means whatever velocity, that will be x. So initial x plus new x plus this velocity will give me the new x. So अभी यहाँ था, अब मेरी position change होके यहाँ पे आ गई. Okay, now 2-3 things are there. Any question on this equation? Is it clear now? So x is position and v is velocity. Velocity into time is distance. Time is 1 because I'm calculating in every iteration. So I'm adding velocity to my position. So I'm here and I reach to a new position. So now the interesting things in this equation is what is omega, what is v, what is C1, what is C2, PID and GID we calculate basically. That comes from the problem. So these have certain impact. We'll study what are the impact of these parameters. So the few more assumptions. This one is basic PSO I'm talking about. I'll talk about some variants also. That particles never die. We entered 30 people in this room to search, 30 remain there. Let's assume it. Okay. बाद में बात करेंगे कि who will die and who will not. Okay. Then particle can be seen as a simple agents. They can move, they can record. Initial values of velocity are randomly generated between a range of maximum velocity or minimum velocity. And once the particle compute new xi, it evaluate it and store it. Because when you move from this position to the next position, you have to see whether the coin is there or not. And if it is not, then record it. Either be coin nahi hai, let's move further. So this is how these things work. Okay. Okay, when using PSO, it is possible for the magnitude of velocities to become very large. So now the first thing is initial velocity, whether it should be slow or it should be large. And this one is very important. Now you just remember remember your friends with whom you are searching in this room. Okay, you can have 2 kind of friends there in your room. One of your friend is, you ask him, okay, search this thing. He run from there to there, there to there, there to there, keep on running. You can have such kind of friend who is very fast, want to do things very fast. And another friend is, you give him a job and forget it when he will complete. He move very slowly, coolly, very slowly. We have these friends. That is the initial velocity, and both are dangerous. जो बहुत तेजी से भाग रहा है, वो गोल्डन कॉइन के ऊपर से कूद के भाग जाएगा, उसको दिखेगा ही नहीं कहाँ से, है ना, उसको मिलेगा ही नहीं, वो उसके ऊपर से कूद जाएगा, फिर आएगा, and whole day after running he will say that there is no coin in this one. And the person who is very slow, it will take a lot of time to reach that coin because it's doing very slowly. So you have to make a balance between the initial velocity. It has to be decided. Again, I'll repeat, it varies from problem to problem. Okay, so that is the point on the velocity. We'll discuss more on that things. This one is story. I'm skipping some of the stories. So this one is better way of writing the same thing. Velocity at n plus 1 instant is vn. Omega इसमें 1 मान रखा है. They assumed 1. C1 rand personal best minus current position plus C2 into random number G best group best minus current position. So this is what we have already talked about. This one is a better way of writing the same thing. There's nothing new to this. Now the parameters we are talking about is very important. Controlling velocities, swarm size, inertia weight factor, which is omega, C1 and C2. Okay, so first part we have already discussed. Some of our friends are very fast in moving here and running, and some are very slow. Second one is swarm size. How big should be the swarm? So if I ask in this room, if I put 1,000 person and ask them to search, they even cannot bend. They will create a problem. So this one is dangerous. If I ask only 2 of my friends to search, me and one my more friend, again it will take a lot of time. So I have to make a balance, seeing the size of this room, what is the proper number of friends required to search that coin. Normally in most of the problems, around 25 to 30 size is quite good enough to solve your optimization problem. So that is the second controlling factor, swarm size. Third one is inertia weight factor. Inertia weight factor, which is multiple of initial velocity. Very important. And we humans have that factor. It varies. Some are very rigid. You need a lot of time to convince them, do it man, this is good for you. They have a very high inertia. You cannot change their think process. And some are having a very low inertia. You just tell them, they are so convinced, okay, let's do it, they are ready. So that factor also governs the convergence process. That is basically your omega. In a basic PSO, they fix the omega. Okay, but later they make it variable. Reason is very simple. Initially, you can move faster, but when you are near to the solution, you should move slowly, and that is governed by your omega. Initially, you make omega large so that you can move faster, and then you make omega slow so that the movement is slow because you are near to the solution. So that is basically omega. Third factor is C1 and C2. Very important factor. C1 and there is C2. C1 is multiplied with some value, that is personal best minus current position. C2 is multiplied by global best minus current position. Okay, let's understand this problem in that way. I make C2 0. I make C2 0. That means I'm not taking any input from my friends. Highly egoist person. We are. What I am doing, that is correct. I'm not going to listen what you are saying. That means my C2 is 0 and my C1 is high. This one is dangerous. Second side, I make C1 0 and I take C2 high. That means I don't have faith on myself. Even I want to purchase a pen of 1 rupee, I'll give a 10 rupee phone call to my friends, which pen is good. Because I take a feedback and then I take a decision because I don't have faith. So I listen to everybody. So that means C2 is high for that particular person and C1 is low. We have to make a balance. That means that's a balanced person. The thumb rule they put it is, there is no any mathematical proofing, but after experiments they come out C1 plus C2 is equal to 4. So based upon your problem, then you can vary. Okay. So these are the controlling parameters which have in developing this algorithm. So now let's write down the algorithm steps. Basically, as PSO is over. PSO is over. PSO parameters over. So what is required? Initialize the particles, place them randomly, evaluate their fitness, calculate the velocity, move the particle. You have to do nothing more than that. So randomly place. So first step, I'm here. That is first step. I know what are these coordinates. Put in the function, evaluate it. Velocity I have to calculate. So I need my personal behavior, my friend's behavior. From that, I'll get information. I'll take a next step, and like this. Is that clear? No. Is that clear or no? Algorithm part. If no, I'll explain it in a different frame also. I'll put it here exactly. Yona? Okay. You can take it this one. Say my problem is of two variables. So I have function which I want to optimize, which is a function of x1 and x. So what I have done? First step. Okay. The first step I'll do is I'll take 1, 2, 3, 4, 5, say 35. This one is my first step. Okay, and randomly I choose what is this value, what is this value, what is this, what is this, what is this. Randomly I choose these values. That is a step 1 and 2. Third, I have to evaluate the fitness. So I put these values in this function, so I'll get f. Fine. Then calculate the velocity. So velocity formula I know. V is nothing but omega into V volt plus C1 which I have fixed, rand which I have fixed, multiplied by personal best minus x I plus C2 rand G best minus x. Fine. Since it is a first iteration, so my personal best and my current is same. Is that okay? So this part becomes 0. Okay. What I am calculating is V. C2 rand G best. From here I'll find out say minima problem. What is the minima? Say this one is minima. So this one is G best minus personal position. That will come here. That will give me the value of V here. This V I add here and here. I'll get X new, X1 new, X2 new. That's cut off. Next time these two comes here. Again evaluate. Now your personal best remain, because when you calculate this one here, either this one will be good or the previous one will be good. If previous one will be good, that remains, that comes here. If this one is good, again it becomes 0, and likewise. So this is the algorithm how it works. So only 1, 2, 3, 4, 5 lines in a column, it will give you the solution. So you can write it in a different frame. Initialize, calculate this, calculate P best, calculate G best. The same thing you can repeat it in various frames. So I'm skipping this one. This one is a way of writing the things. You evaluate a pseudo code. You do the Google, you'll find a lot and lot of such equations written here. Equations are all are same. Okay, so I'm just skipping these parts. Now, how this algorithm is giving us a global solution? So there are two randomness. One randomness is your with the personal behavior that is connected. Okay, we are using a rand function with personal behavior. We also using rand function with global behavior. So two randomness is incorporated. So analogically, we can compare it with genetic. There also we have two kind of randomness. One is crossover, another is mutation. Same thing is coming up here also. So this helps us in getting a global solution. Okay, this one is just slide to see how they move by iteration and iteration, and finally they reach to the global optimal solution. Okay, so that you can have. Now some changes. This one which we have discussed. First topology of group information is this one. Okay, this one is ring topology. So if you go by this, then this person only here for him G best will be the information of second and 30. If I go by ring topology, I compare with each and every. Oh sorry, star topology. So I compare with each and everyone. Then I'll see which is the best among both. Both have their own benefits, and then C1, C2 we have already talked about. This one is results people have obtained from different experiments, that C1 plus C2 equal to 4 is a good good for getting a solution, and particle between 10 to 50, normally they work around 25 and 30 is good to get the solution. These are some functions, benchmark functions. So those who are interested in developing new optimization algorithm, they have to test on certain benchmark problems, and these are known. These are few example of that one. So if you are interested in developing new algorithm, check your algorithm on CEC problems. Basically, you can download it. It is given on the net. CEC problem. Now to CEC 2016 is also there. So if you prove if you obtain better solution on CEC problem, then only in research arena your algorithm is better. If you are not getting good results, that means other algorithms are better than you. So those who are interested in developing new algorithms, they are comparing their algorithm on CEC benchmark problems. Okay, so these are few of them. So you can see the comparison of results. Okay, it's a 3D, 30 dimension. You cannot think after 3D. This one is 30 dimension problem. Okay, so this one is Gribank, Resting, and Rosenbrock. Evolutionary algorithm, and you can compare PSO. In first, we are looking for maxima. In second, we are minima. Second, we are looking for maxima. In third, we are looking for minima. There is a big variation. So PSO is much easy, much faster, because only one equation solve our purpose. It is faster than your genetic algorithm. People have tested on different problems also, and it is more accurate also, because one level of randomness is reduced in this section. Okay, so then adaptive. Two kind of adaptive. This is not a good way to say, but for a system it is always good. I have gone through enough improvements. I am still the worst. So the way is I kill myself. It's not a good thing, but people do so. People do so. But the same thing for a group is good. When people are looking for a group behavior. So that means what? I have 30 swarms. Say last 2 are not improving at all. So you kill them, you replace them. You replace them with best. So that is the second part. I am the best, but has not enough improvement. I generate a new particle near around me. So that 13 figure remains same. What I'm doing is I'm killing the worst, replacing those worst with some particles which are near around the best. So this one is one kind of adaptive particle swarm optimization technique. You can have different combinations. This one is one of them. Okay. Second one is coefficient adaptation. I told you that omega. You can fix omega, but you can make omega as a function of iteration. Initially, I need high omega. After that, I need a less omega. So I can make omega as a variable. So that is also another kind of adaptive swarm optimization technique. Okay. You can create changes in the velocity. So there is a lot of this. This one is pseudocode, again the same thing. So this one is one example people have tested on the same platform. Now this one is important. Platform is same, machine is same, particle size and population size in one is 100, both they are same. Simulation runs are also same. Crossover probability is taken 0.9 and mutation is 0.1 on certain problem. And just to observe the convergence process, you can see that PSO is converging faster than your genetic algorithm. Just to give you an idea that in most of the cases, I'm not saying in all the cases, but in most of the cases, this one is performing faster and better than your genetic algorithm. This one is an experiment done by a scholar at IIT Mumbai. So I'm sharing the results of that person. This one is curve fitting, model fitting technique. So they have experimental data and they have measured data. So they are proposing a model for it. The object is to find out the parameters of that model. Okay, many a times I have some kind of equipment with me or some kind of system with me where I have experimental data with me. I want to find out what is the mathematical equation of this box for my research purpose. It's not very easy. So what I'll do, I write down some kind of equation and then I give those input, try to see that my outputs are near to that particular outputs or not. Then I do the change in the parameters to get the perfect model. So this one is basically MOSFET modeling they have done, and you can see that the experimental results and the proposed model is almost perfectly aligned with each other. So this one is parameter MOSFET parameter extraction experiments done and reported by IIT Mumbai researchers. So I'm just those things I just want to share with you. It's okay. Experimental and model. So you can see the measured one and the model one, they are perfectly aligned with each other. So you can have perfect model of certain things. Black box modeling, you can say. Different parameters of MOSFET, they are compared and reported here. Okay, another one is this one is well known problem in electrical engineering, economic power dispatch problem. Okay, so this one is a function. 6 functions are given. That means 6 sellers are there. Six shopkeepers, we can say. 6 shopkeepers are there. They have certain range, and I have to buy things. One is 800 megawatt, 1200 megawatt, 1800 megawatt. What is the best combination? Or you can say those not from electrical engineers, 6 shopkeepers selling sugar of different rates. They have limited capacity. You want to purchase sugar of this much capacity. How much to purchase from which person? That's basically a problem of economic dispatch. And we tested that genetic and PSO and variant of PSO is there. So it performs, you can see at the total end, at the cost side, at the end, you find that PSO is performing better and variant is again performing much better than the genetic algorithm. So these are some results to just give you an idea. And this one is one case when I'm talking about economic load dispatch. I increase the complexity here. I add some nonlinear term responsible for emission part and all that. So when you increase the nonlinearity, you will find that the solutions, there is large variation there. Earlier the variation is not so much, but now the problem become more complex. I have added few complex terms to it. You can see the solution obtained. There's a big difference between the genetic algorithm solution and the solution obtained from the PSO or variant of PSO. Well, thank you about PSO. You know your part. Any questions on PSO? You're most welcome.
जीए का टूल बॉक्स खत्म हो जाता है ऑप्टिव टूल से, तो उसमें क्या पीएसओ का भी कुछ टूल बॉक्स
ऐसा इन्होंने ऐड नहीं किया, लोग ऐड कर दें, बट लोगों ने एल्गोरिथम बना के रखे हुए हैं। टूल बॉक्स मैंने देखा नहीं है, मेरे ख्याल से है नहीं, उनके ऐड नहीं किया हुआ। बट व्हाई देयर इज ओनली वन इक्वेशन, व्हाई आई नीडेड टूल बॉक्स? देयर इज नथिंग हियर, मींस हमें कुछ कैलकुलेट नहीं करना है, आप हाथ से भी कैलकुलेट करके इसको देख सकते हैं। I have to just write down this matrix 1 2 3 4 5 6 line matrix. I have to prepare this one randomly, these variables. So there is nothing to do, randomly you select these variable in the range. Say your equation which you want to optimize is x1 minus 1 square plus x2 minus 6 square in the range of minus 6 to plus. This is the problem given to you. You can choose these numbers 1 0 minus 3 4 minus 2 2 5. Randomly I am picking numbers between in this range. That is step 1. Then I substitute these values here, calculate these values. Once this one is over, I have to calculate the velocity. This I know, initial velocity I know, C1 I know, C2 I know. Randomly you can choose any values. P best you can calculate from everyone, and G best, what is the best among these. So you will get the new value of V, add that to these values, you will get new values of X. You keep on repeating this.
सर जैसे कि रैंडम वैल्यू हम चूज कर रहे हैं, तो हर रैंडम वैल्यू के लिए डिफरेंट उसका रेस्पॉन्स आएगा, फिर हम ये कैसे पता लगाएंगे कि क्या है वैल्यू कितनी है, कौन सी बेस्ट वैल्यू है?
बेस्ट वैल्यू मेरे को रैंडम वैल्यू की बेस्ट नहीं निकालनी, बेस्ट वैल्यू तो मेरे को फंक्शन की बेस्ट वैल्यू निकालनी।
नहीं तो सब मैं ये कह रहा हूँ कि वो रैंडम वैल्यू हम कैसे चूज करेंगे जिससे फंक्शन की बेस्ट वैल्यू आएगी?
रैंडम वैल्यू तो चूज ही नहीं करनी, रैंडम तो रैंडम वैल्यू है, नहीं रैंडम तो रैंडम ही है। आपने 1 0 to 1 की रेंज में रैंडम वैल्यू कुछ भी लेनी है, तो अपने आप ही आएगी जो भी आएगी। Randomly you choose it, otherwise then it will, if you choose it then it is not random search, then it is guided search. There are algorithms which are known as guided search based algorithm. So if you guide them, then it comes into the category of guided search method, otherwise it comes under the category of random search.
दोनों में तो मेरे हिसाब से गाइडेड वाली ज्यादा अच्छी होनी चाहिए।
कई बार सही हो सकती है, कई बार नहीं भी हो सकती, because you don't know the solution, है ना। एक्चुअल में कहाँ पर देखो, मैं आपको एक छोटा सा इसमें, आई डोंट नो, मेरे पास में वो फिगर नहीं है अभी। See this one. Now if this is my function, so I know where is the optimum. Okay, but now imagine this function is 40 dimension. Now you cannot imagine where is the solution, and then it is rotated. So even 2 dimension में अगर मेरे यहाँ पे ऐसा इस तरीके का, if I have this figure in 2 dimension, but if I rotate it by 40 degree या इसको 30 डिग्री कर दो, तो ये यहाँ पहुँच जाएगा, ये ऐसा कुछ हो जाएगा, ये इधर पहुँच गया, मिनिमम कुछ और बन गया। And now if the dimension is 60D, 100D, you don't know where is the solution. In that case, you guided will create a problem. You have to go for it. Yeah. Any other questions?
So, sir, is there any tool for PSO like we have GA tool in MATLAB or some other software?
No, tool is not there, but yes, people have algorithm in MATLAB on the Google, so you can get good algorithms from there.
there is no basically in MATLAB.
No, no, I haven't seen. Maybe I don't know the latest version, but I haven't seen that.
Okay.
Some advanced version of PSO and the search-based method, I have put it on my website. You can download it for the purpose. So you can use it.
Okay, sir. Thank you.
Question here. Cordial. Hello.
This one is the site where from where you can download all these presentations and some of the algorithms which we have prepared, and some other useful information also, like how to write a research paper and how to go for a research and all these things. Okay. Yes, please. Any other query? Any other question on PSO?
I hope you had a very fruitful discussion with Dr. Rajesh, and I thank sir for this opportunity you have given for the students and for the participants at various places. Anyone want to ask any questions? Gandhi Academy, Berhampur, Odisha. Want to ask any questions?
Yes, ma'am.
Yeah, we have a question here.
Please.
Sir, is there any method to know that the whole sort space is sorted by at least any one of the particle in PSO?
Okay, you can observe in every iteration where the particle is moving. So you can, from there you can have a whole pattern that how the particle is moving and where that particle is searching.
Yeah, but is there any method to know that the whole sort space is searched?
You can plot it. You know the surface, that this is the surface where I have to find out the solution, and every particle you can plot it in every iteration. That first iteration, what is the location of the particle, second what is there, third what is there. From there you can have idea that how the particles are searching and what space they are searching for.
Okay, fine. Thanks, sir.
Thank you, ma'am.
Any other questions from any of the centers? Okay. Now then we conclude for this session. We'll have the afternoon session at 2. So all of you will have 1 hour of lunch break, and we'll again reassemble at 2, and sir will continue with his other optimization techniques. Here you have only done PSO now, no? Some more optimization techniques he will do now. He will do in the 3rd session. So hope you will all be ready by 2 o'clock. Okay, Monica? 2 o'clock is okay, na? Okay, thank you very much. Thank you, sir.
ਸੁੱਧਾ ਦਾ ਲੰਚ ਬੜਾ ਵਧੀਆ ਅੱਜ ਹੈ। ਚਾਰ ਸਬਜ਼ੀਆਂ ਸਾਗ ਅੱਜ ਬਈ।
गर्मी नहीं है करने हैं। क्या इस्माइल जी की पढ़ती हो कोई जी? अच्छा पढ़ते ही इस्माइल जी लिखूंगा। बुलेट की क्या से माना है? बुलेट की कहा तो कुछ और कहा। बुलेटी का बुलेटी का बुलेटी क्यों? देखियो देखी देखने कसम की सारी मेरी है बाकी लोगों को कुछ शब्द को किसी को पे किए गए हो तो इन दूसरे में ये कुछ नहीं आजा भी आजा भी समोसा बढ़िया खा ले हेलो ठीक है भाई तुम किस टाइम आ गई और बोलता तेरे मेरे रात में हैं कदने आज मेरे तो नहीं मेरे नहीं आज मेरा चल मैं शाम में कर पाऊंगा तेरा भी बता दे बता हां मैं फोन कर लूंगा फोन कर पूछ लूंगा तेरे को भी मेरा फोन यार फोन कर तो वही उसने बात करना है क्यों जरूरी है ये यार कोई ना कोई बोल लेगा कोई तो मेरी यही है गाना बात कर रहा हूँ होगा, लंच ब्रेक हो रहा है। मैडम आ रहे हैं, मैम को बोलना भी कह रहा है 5 मिनट में। हाँ ठीक है जी, आ रहा हूँ। मैडम भी लेक्चर है?
हाँ जी, लैब पे बनानी है।
अच्छा लैब।
चार्जिंग करके लेके आती हूँ, मेरे को लगता है रात को ध्यान देना मुझे, सुबह याद आती है। कुछ होती के लिए किस महीने से मैंने सुना बनाना है कुछ यार मुझे नहीं है, वो भी तो फोटो हो रही है, वो भी तो भी कोई भी काम मतलब होता है यार, कुछ भी 25-26 के आसपास प्लस।
खालिए खाना खाना निकालो अपना मैटलैब लैपटॉप से, नहीं तो यहाँ है सब में मैटलैब निकालो। वो हो गया था ए मॉड्यूलेटर डी मॉड्यूलेटर। अच्छा मैनुअल ले आना था ना ऊपर, मैं मंगवा या जाके ले आओ, नीचे ही तो है लैब, यहाँ से एक जगह जाके ना मैनुअल ले आओ। सेकंड एक्सपेरिमेंट एएम का हुआ था, आफ्टर ये करके ना अपना अगली बार फाइल ले आना, जो जो हो जा रहा है साथ साथ लिख के उसकी वेवफॉर्म लेके प्रिंट स्क्रीन लेके चेक कराते रहो। मैटलैब अब क्लियर है, अब तो बस अपने मॉड्यूलेशन के एक्सपेरिमेंट करो। ये भी अभी जैसे स्टाइल लोग होने लगे, जो भी उन्होंने फिर भेजना है। मैंने कहा अब हम क्या कर सकते हैं, 10-10 बार आ रही लोग रिवेल के लिए अप्लाई कर रहे हैं, सब भी जा रहे हैं, जाना तो पड़ेगा एक एक सब्जेक्ट के लिए।
13 सब्जेक्ट्स हैं। दीपक शर्मा कर सकते हो?
दीपक शर्मा देते तो हमें पहले भेजा नहीं है ना, क्योंकि इस पीरियड में इनके साइन कराना ठीक है, कोर्स वर्क में है ना, दोनों को छोड़ दो। पहले भी नहीं मैंने कराया इनके, नहीं भेजे हैं। तो अब तो टूल बॉक्स अवेलेबल, आप टूल बॉक्स भी यूज कर सकते हो, आपको बनाना तो आ ही गया। नरेंद्र जी, वो डॉक्टर शरद को जो जो कहा हुआ था ना उसकी लिस्टें मंगवा लो, मुझे लिस्टें चाहिए सारी, कैरियर 360 वाले की, और भी अपनी फाइल में चेक करो, एक ओलंपियाड था शायद, और एक और देख लो जो जो भी इनको दिए जिसकी लिस्टें नहीं आई। हाँ हाँ, ये भेजना है बच्चे। हाँ, मंडे से, मंडे ट्यूसडे वेडनेसडे। आपके भी है ना डेटशीट, एमटेक के भी साथ ही होंगे।
उनकी बनाने के लिए मैंने बोल दिया दीपक शर्मा जी बनाने के लिए।
ठीक,
वही बनाते
एमटेक की धर्म गुलाटी कोऑर्डिनेटर।
हैं वो दोनों।
हाँ, दोनों ही है ना, ठीक है। उसको बोलो कि कोऑर्डिनेटर कुछ तो जब तक है कोऑर्डिनेटर काम तो करो। मैं क्या करूं? हेलो हेलो, हाँ जी, हाँ जी सर। सर आप लगा के आए थे वहाँ चक्कर? अच्छा अच्छा, हाँ हाँ। अच्छा, तो लिनक्स में तो हमारा लैब भी चल जाता है सर, वैसे तो कोई प्रॉब्लम है नहीं। अच्छा, वहाँ फर्स्ट फ्लोर पे है या नीचे ही है सर लैब? कितने पीसी हैं सर वहाँ पर? अच्छा, 40 पीसी हैं एक ही लैब में, फिर तो ठीक है सर। अच्छा अच्छा, बस ठीक है। और सर प्रोजेक्टर वगैरह लगने का है, सारा लगा हुआ है? अच्छा अच्छा, ठीक है सर, फिर वहीं रख लेंगे ट्रेनिंग का। अब हमें नेक्स्ट स्टेप ये करना है सर, वो देख लें हार्डवेयर वगैरह कौन सा आया, वो लेके लैब में रखवा देंगे कल। हाँ, कल सुबह करेंगे ना, कल वो करण फ्री हो जाएगा, उसको भी वहाँ ले लेंगे साथ ही, जहाँ जहाँ होगा वो रिसीव करके वहाँ रखवा देंगे सारा सामान। और सर इनका चाय पानी का जो टीम आएगी मंडे से, कुछ मतलब हमने डिपार्टमेंट लेवल पे करना है या कुछ, वो भी पूछ लेंगे, है ना सर? अच्छा 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 अच्छा, चलो ठीक है सर, फिर कल सुबह एक चक्कर लगाएंगे वहाँ पर ना। ठीक है सर। सिर्फ इलेक्ट्रॉनिक की वजह से पूरे सेशन प्रीपेंड हो गए इस ट्रेनिंग की वजह से। कोई डाउट तो नहीं? मोबाइल मोबाइल छोड़ दो और 2-3 एक्सपेरिमेंट कर जाओ। कोई नहीं, सेशनल तुम्हारी तैयारी है, और क्या करना भी।
12 स्ट्रिक्स हैं।
हाँ जी, हाँ जी सर, आगे कर लो। वो कहाँ है जो आई थी?
12 स्ट्रिक्स हैं।
जी सर। ट्रिपल ई से, अच्छा ये सारे ले लिए ना आपने? यहाँ ले लिए।
जैसे ट्रिपल ई में
हर टीचर कवर हो गया? कोई ऐसा टीचर ना आया हो?
मैं नहीं हुआ।
अच्छा,
एक करण नहीं हुआ।
आप और करण, ठीक है।
लगभग और कोई रहेगा।
अच्छा, नेटवर्क थ्योरी में कौन डाला है?
अनुज गोयल।
करण डाल दो यहाँ, करण ने पहले करी हुई है।
ज्योति
वो तो मिले नहीं। गीता मैम आ गई?
आईटी
करण को कहीं डालना, आपका तो चलो कोई नहीं, बनाया है इसमें, काम तो कर रहे हो। करण को कहीं डलवा दो।
ट्रिपल में 2 डाल दें, ट्रिपल की ज़्यादा होंगे।
ज़्यादा होंगे? ट्रिपल में 2 डाल दो।
वैसे इन्होंने हर एक में 2-2 मांगे हैं,
एक एक ही भेजेंगे, इतने तो है ही नहीं हमारे पास। कोई रह तो नहीं है और टीचर? कल से तो कम हुआ है खबर।
12 हो गए, 2 हो गए 14, 2 हम हो गए 16, 1 था करण।
तो करण नहीं है, और 2 को तो उनको तो लगाने भी नहीं, रोहित
नहीं नहीं,
डिप्लोमा वालों के तो वो तो उसकी करते हैं ना डिप्लोमा के।
नहीं टोटल 12 तो ये हो गए।
2 जिनको छोड़ा 14, 2 हम हो गए 16,
एक करण हो गया
17, 2 लगानी भी नहीं, जैसे अभिषेक इसकी लगी नहीं, वरुण, रोहित लांबा,
19 और एक 20। कपिल, डॉक्टर कपिल कह रहे थे कि मुश्किल है, काफी काम है,
हम उनको रहने दो, ट्रेनिंग का भी कर रहे हैं,
इसलिए मैंने उनकी नहीं की।
करण की लगा दो कहीं,
फिर ट्रिपल में डबल कर
ट्रिपल में कर दो। EMFT का भी उसने बनाया था कि सिलेबस का नहीं है?
मैम करण नहीं किया होगा, ये भी देखा।
करण ने कर रखे हैं पहले, जैसे अच्छी बात है, मुझे लगा पहले उसका नाम नहीं आया। ट्रिपल ई में 2 जने कर दो। हाँ हाँ मैं आप बोलते रहो।
मैम ट्रिपल में हरीश बंसल, ओब्लिक करण,
कैसे करूँ सर इसमें?
ओब्लिक करण,
नेटवर्क
मैनेजर,
इंजीनियर ना लिखो
ना
वही तो कह रही।
एनालॉग एंड डिजिटल में अनुराधा, डीएसपी डॉक्टर मुमता।
हमने तो ना किसी का सिलेबस बनाया है ना हमने, मैंने कहा आप लेते हैं प्रोजेक्ट लैब में, क्या करें प्रोजेक्ट लैब के मैनुअल में कहीं तो डालना ही पड़ेगा, आप बता दो जिसमें डालना।
हाँ वो भी चेंज करना, तो कौन सी लैब कह रहे थे?
डिजिटल इलेक्ट्रॉनिक्स में डलवाया ठीक है, एक में तो डालना ही है। आगे ACET
अभिजीत,
ITC कर लेगी गीता मैम, माइक्रो प्रोसेसर
कर ही लेंगे,
वो सबके कराते हैं, माइक्रो प्रोसेसर
उनका पूछने की जरूरत नहीं होती कि करेंगे।
माइक्रो प्रोसेसर
पूजा क्वेश्चन मैम देखना, कोई ऐसा तो नहीं होगा जिसका यहाँ पे
नहीं मैं चेक कर रही हूँ साथ साथ। माइक्रोवेव
हिमांशु,
WMC डिजिटल कम्युनिकेशन
डॉक्टर कुलदीप,
डिजिटल इलेक्ट्रॉनिक्स EMFT है बस ठीक है दे देते हैं।
ये नया ही ना बनवा के मैम से यहाँ साइन और फोन नंबर भी आना है।
वो बनाता तो हर बार शायद नहीं बना के
ना ना वो इसी में भेज देता फोन नंबर वगैरह नहीं आता।
फोन नंबर तो लिस्ट लगा दो ना साथ में टीचर्स
एक्सपर्ट टू सब्जेक्ट्स एक्सपर्ट विद टेलीफोन
ऐसा है, इसके साथ लिस्ट अटैच करवा दो। नहीं वो पिछला जरूर मांगते हैं ना, ये देखने के लिए कि पहले किसने किया। दोबारा कहाँ इतना टाइप कराओगे, एक लिस्ट लगवा दो ना आगे फोन नंबर की। टीचर
मैं साइन में भी फिर वो ऐसे ही कर दे।
साइन तो छोटे छोटे करने हैं क्योंकि बस एक ही में सब कुछ हो जाता है। भेज देगा वो, जैसे भेजता है वैसे चलता रहेगा। किसी ने मना करा आपको? वैसे नहीं आ रहा, जैसे यूनिवर्सिटी में चलता आ रहा
मैं किसी को वैसे नहीं
है।
आपसे कौन सी कॉम है किसी को वैसे
क्या आपका नाम नहीं है तो इसी में डरते रहा करो बस। अब तो यही भेजूंगी मैं, नीचे लिखा है अंकुर सिंगल बना के। कब तक डरोगे सर, कब तक अपनी पोजीशन से भागोगे? है तो है उसका, करो कि हाँ काम नहीं कर रहे। तो कोऑर्डिनेटर को हर जगह मैं बुलाती हूँ, कुछ करती हूँ तो बोलो ना को तुम बन जाओ। मैं तो जो मुझे कहता हूँ कहता हूँ बैठो तो सही सीट पे, आओ नजारा लो, कोई प्रॉब्लम नहीं है सर, इस सीट पे बैठो और मत करो। मैं तो ये खुश हूँ, मुझे ड्यूटी लगाओ, मैं एक पेपर चेक करके आऊंगी, साथ में थोड़ा घूम भी आऊंगी। ऐसा कुछ नहीं है सर, डोंट वरी। हाँ जी, हाँ जी, बैठो बैठो। हाँ जी,
मैम ये टाइम कैसे निकाला मैं यहाँ पे?
हेलो, हिमांशु वो करवाना पार्ट टाइम वाला, तो मैं 220 लैब में हूँ। हाँ कोई नहीं, इसके बाद करा लेना आज पार्ट टाइम, ठीक है। जरूरी नहीं है आपने इनका यूज करना है, देख लेते हैं इन्होंने भी क्या किया। इन्होंने ना सैम्पलिंग टाइम से इन्होंने नॉर्मलाइज किया है, जो हमारी फ्रीक्वेंसी है उससे डिवाइड करके, डिवाइड का मतलब होता है नॉर्मलाइज करना। जब हम किसी चीज को नॉर्मलाइज करते हैं हाईएस्ट रेंज से डिवाइड करते हैं, वो काम किया, नॉर्मलाइज किया।
मैम ये ऑपरेटर क्या यूज किया?
ये तो वैसे ही उसका ना क्या कहते हैं उसे, मेरे ख्याल से ट्रांसपोज लिया उन्होंने डिवाइड करने के लिए ना, उसको वो करके देख लो, डोंट वरी। मैं तो कुछ करती नहीं, बस इसको उठाया वहाँ लिख के देख लिया। प्रैक्टिकल तुम्हें आंसर मिलेगा अपनी बात का। मैटलैब में तो फायदा ही बहुत है, खत्म। मैटलैब इटसेल्फ इज अ सुपरवाइज्ड लर्निंग, टीचर इज अवेलेबल, यही तो इसकी ब्यूटी है। बस यहाँ लिखो, तुम्हें खुद ही आंसर देगी, ठीक है ना। अब आपको टी चाहिए, ये हो रहा है टी में, ठीक है ना। ये एक्चुअली बहुत ज़्यादा भर गई थी, 5000 तक पॉइंट है ना। एफ एस ई है, एफ सी ई है, ठीक है ना। आपका मकसद सिर्फ ये देखना है ये क्या करता है, और तरीका कर लो। सिर्फ तुम्हें दिखाने के लिए, वैसे मैंने बता ही दिया तुम्हें। 0 to FS, ये 0 to 8000 पॉइंट है, हम 8000 नहीं लेते। आपने तो अभी समझना ही है ना, 0 to 10 ले लिया, ये आगे, ठीक है ना। अच्छा जी, इसको रिपीट कर लिया। अब आप कह रहे हो डैश का मतलब, डैश लगाया मतलब ट्रांसपोज हो, सिर्फ उसको रो में ना लिख के कॉलम में लिख लिया। डिवाइड बाय प्रेस कर दिया, डिवाइड किया, जो भी आपकी सैम्पलिंग फ्रीक्वेंसी जैसे 100 की हो जाए, नॉर्मलाइज कर लिया उसको एक रेंज के अंदर, ठीक है ना। और अगर हम ट्रांसपोज के बिना करें, दिमाग में तो चीज़ें आती हैं कि कहाँ एरर आ रहा है, तो इस तरह आएगा। वो कहीं आगे मल्टीप्लाई करना होगा, तो इसलिए उन्होंने ऐसे कॉलम मैट्रिक्स बना के रखा है, और कोई बात नहीं।
तो मैम उसमें किया हुआ है, एक पूछना था आगे, जो इनपुट सिग्नल लिया है एक्स मॉड्यूलेटिंग सिग्नल, उसको इन्होंने 2 चैनल में लिया, हम नॉर्मल एक्स ले सकते
2 चैनल, हाँ वो भी ले सकते हो। अब इनको 2 चैनल ही चाहिए ना, तभी तो तुम उन्हें एक ही जगह दिखाओगे दोनों को मॉड्यूलेट होकर। ये एक्स को 2 चैनल सिग्नल एक ही में लिया ना, एक्स के अंदर ही, ताकि एक्स को इकट्ठे प्लॉट कर दिया इन्होंने। एक एक करोगे तो एक एक प्लॉट होगा। लग करके देख लो, इकट्ठा करके देख लो, बड़ा मजा आता है इसमें, करके देखो ना। अकेला करके देखो फिर इकट्ठा, आपको खुद ही मैं जो कहना चाह रही हूँ उससे ज्यादा आपको मिल के आंसर मिल जाएगा। ये 2 चैनल कंबाइन हो गए, इसे कहते हैं कंकैटिनेशन ऑपरेटर। इससे दोनों इकट्ठे हो गए, इकट्ठे आएंगे। अगर आप अलग करोगे तो एक S1 का प्लॉट आएगा, एक S2 का। आप तो मॉड्यूलेट करना चाहते हो ना, हाई फ्रीक्वेंसी के साथ एकदम लो दिखाना चाहते हो, वही कर रहे हो ना, कंकैटिनेट होकर आएगी। अदरवाइज आपकी 2 ग्राफ खुलेंगे, एक में हाई होगी, एक में लो फ्रीक्वेंसी होगी, ठीक है। अब तो आपको टूल बॉक्स अवेलेबल है, आप टूल बॉक्स यूज कर सकते हो। पहले टाइम में टूल बॉक्स ही नहीं थे जब मैंने किया, तो हम खुद बनाते थे, उससे और पिक्चर आ गई। अब लोगों ने क्या किया, इसके टूल बॉक्स बना बना के इसके पीछे लगा दी। आ गया ना सारा, ये रन हो गया पूरा प्रोग्राम। अब डिस्प्ले क्यों नहीं हो रहा, क्योंकि कॉलन लगा हुआ, जब तक कॉलन है तब तक डिस्प्ले नहीं होगा, ठीक है। FM मोड, अब आपको चाहिए मॉड्यूलेशन, पहले वाई चाहिए ना, ये वाई के आगे 2 चैनल के देखो पैरेलल आ रही है, नहीं तो एक आएगी तो एक को। अब इन्होंने प्लॉट नहीं किया हुआ इसके अंदर, अगर प्लॉट करेंगे, अगर इसके अंदर प्लॉट करेंगे, प्लॉट अभी करा ही नहीं हुआ, अभी सिर्फ वो दिखा रखा है उसका मॉड्यूलेशन। FM मोड जो सी है, ये आपका रेडी में कमांड यूज की, उसके अंदर एक इनपुट होगी, दो आपकी फ्रीक्वेंसी होगी और एक ही होगा। इसका भी हेल्प FM मोड लिख दो और ये देखिए यही देखना चाहिए। FM मोड का मतलब है पहले आपने इनपुट देनी है, फिर दो फ्रीक्वेंसी और फिर फ्रीक्वेंसी डिवीजन। Modulate the message signal X using frequency modulation technique. The carrier signal has frequency FC. ये carrier sampling rate is FS and FS must be at least वो तो होता है। Frequency deviation augment is the frequency deviation constant of the modulation. कितनी deviation नहीं भी दोगे तब भी चल जाएगा। तो ये कैरियर और आपकी मॉड्यूलेटिंग सैम्पलिंग फ्रीक्वेंसी दोनों आई है। कैरियर को कितने पे सैम्पलिंग करनी होती है और ये इकट्ठा इन्होंने यहाँ, ये तो इसकी रिक्वायरमेंट ही थी इसलिए इकट्ठा लिखा है यहाँ पर, ठीक है ना। और एक सिग्नल 2 चैनल सिग्नल लिए इसलिए लिए, ये दोनों इकट्ठा कर दिया 2 चैनल सिग्नल। सिंगल भी लेके चलो तब भी चल जाएगा, कोई प्रॉब्लम नहीं आएगी।
एक फ्रीक्वेंसी
इन्होंने एक हाई और एक लो लिए ताकि डेविएशन रेट पता चल जाए। सिंगल भी लोगे तब भी चलेगा, कोई प्रॉब्लम नहीं। ऐसे कर करके ना एक एक कमांड को चला के देखा करो, क्लैरिटी बढ़ेगी उतनी। यही मैटलैब का अभी टूल बॉक्स का ना कल फिर है सेशन 2:15 से 4। और न्यूरल और फजी की कल एप्लीकेशंस होंगी, और जो कल तुम्हें मैंने टूल बॉक्स सिखाया था उसी में इनको ट्रेन करेंगे ये न्यूरल को मैटलैब के अंदर। ये सुबह वाला जरूर अटेंड करना। कल सुबह आपका क्या शेड्यूल है? 10 से 11:30 है ना। इसमें चलो यहाँ पे देखते हैं टूल बॉक्स के दिन मैटलैब भी सिखाएंगे। वो जो एक्सोर की प्रॉब्लम आई थी ना, यहाँ से डिस्कस भी कर लेंगे, देखते हैं ये वाला सिखाएंगे। एग्जामिनेशन शेड्यूल भी आ गया बच्चे, फाइनल एग्जाम का भी आपके 15 अप्रैल से शुरू हो रहे हैं, ठीक है ना। तो तीसरी क्यों नहीं आ रही? कन्वोकेशन है उसकी 27 को, फिर से उसे को रोए ना, उसने जो कपड़े तैयार किए हैं 27 को यूज हो जाएंगे। 27 की आ गई है, उसे बता देना, बल्कि उसे आज बता देना, अपने दोस्तों को भी बता देगी 27 की है, अखबार में भी आ गया। टिकट बुक करा लें सारे।
ये आपका वो चल रहा है ना सर, पेन ड्राइव, इसी से वो जो लेक्चर्स है ना वो ऑफिस में प्रेजेंट करोगे पीपीटीज।
हाँ बाकी ऐसे ही चाहिए था, ऐसे में पासवर्ड प्रोटेक्ट, ओ सॉरी पासवर्ड वाटर मार्क मैंने डाल रखे हैं साइड पे, वो देखो मैंने, ये तो वाटर मार्क नहीं है, सिंपल एक वाटर मार्क है जो मैंने डाल रखे हैं वो लगा है थोड़ा प्रोटेक्शन।
Good afternoon to all of you at the different centers. Hope all of you are listening to me. Hello? MM Engineering College? Hello? Are you all come back from lunch? Vijayawada, PVP Siddhartha?
Yes, ma'am.
Yes, okay. Good. So we'll be starting with the next session now. Over to sir.
I welcome you on this session, and I'm going to discuss a very new optimization algorithm developed by me on how the bees work in nature and a new version of it. So before moving to the presentation, I would like you to see one clip so that you can have an idea that how things are working, and then we'll discuss the algorithm. Okay. How people observe it very carefully, that they are behaving in a certain kind of a pattern. These are the research made by bio people, and that pattern is having some kind of information. I'll discuss more on it, and these informations I have used to develop a new algorithm which is known as directed bee colony optimization technique. So I'll discuss how I started it, what motivates me, and how I have done it. Okay, so I think you have seen this clip, which is very informative, very small one, but informative one. So I'll talk about development of directed bee colony optimization algorithm. This one is very new, published last year. Only one paper, or now 2-3 more papers are there on it. People are still working improvements on it. So to discuss over it, again, these are the things which we have repeated. So I skip those things which we have repeated in the morning. And again, this one is a slide which give you idea about what is strong global minima, local, strong local, weak local, and strong local minimas. These we have discussed again and again. Again, these are the major techniques which are, this is a bit new. So major techniques which are used in optimization. We have certain kind of constrained optimization problems where people have used leapfrog, linearized search, simulated swarm, colonal, ant colony, co-evolutionary, directed search, evolutionary computing, feasible directed method, and this one. Then there are multimodal problems where people have implemented evolutionary immunity-based random search, simulated annealing, swarm intelligence. Then there are problems which are multi-objective, where people have used fuzzy arithmetic, goal programming, heuristic, unity-based, swarm intelligence, taboo search. Then there are problems dealing with the real life design requirements and increasing designer confidence. These are the various problems, various type of problem where people have used all these techniques in a different applications. Well, I'll discuss more on this one, that how bees are they work in nature and how they motivate researchers to go for to design an optimization technique. Okay, so basically two researchers, Professor Pessino and Selle, they worked on it, on the study of the behavior of bees, how bees work in the nature. And let me share with you, this one is the most organized working system in nature right now. They work in a very organized way. So they behave, their behavior and their response, how they do it. They Professor Selle, he did checked each and everything personally. So what he did is he took some bees to some island and put stickers on each bee, and every day morning to evening he watched how that particular number bee works. Basically from there he classified the type of the bees, their working, how they move, how they take the decision, spend around 10 years with bees, and they come out with some kind of the findings. And since this one is more organized and they do the things in a more very composite way, that attracts other researchers also and attracts me also to work on it. And I create one kind of, so earlier we have bee colony optimization technique, which is already available, artificial ABC or BCO, it is already available. I tried to mix it with some deterministic approach to get some advantage of that, and so that's why I called this directed bee colony optimization. I'll explain you why I called it directed bee colony optimization. So the best part is decision making, which is a good feature of bees and which is very helpful while designing this algorithm. So how they work in nature. So this is the working process basically. Initially some bees they go for searching the nectar sources, where is the nectar. Then the bee loads the nectar and return to the hive and perform the waggle dance. So the movie what you have seen, that is basically waggle dance. When they come back to the nest, then they dance there basically, and that dance is having so many information in it. So the waggle dance give information about the quality, distance and direction of the flower, or where is good nectar, where is good food quality. For them food quality is the objective. For we people who are working in optimization, food quality means the objective solution. Okay, the required bees will evaluate, then the rest bees they evaluate the quality of the food, and then they take a decision, should we go to that place or not, or to get more of it. So this is how they work in the nature. Then decision process, because they have to decide whether this one is good. There are two kind of decision in honeybees. One is consensus, where everybody they take an agreement on this one. It's an agreement based decision process. And second one is quorum based. So they go for a quorum. So it is just like a parliamentary system there in itself in bees also. So once they are agree, one is everybody agree on it, so they go for that particular food, as they go for voting also. And if the interesting part is, if the voting is tie, many times it happen that between two solutions they have tie. So what they do, then they reorder, or they put 5 or 7 new bees to visit both the sites and come out with the quality of the food, and then they take a decision. So the decision is very much democratic way of doing the things, and it's very nice way how they do it in nature. So we have incorporated both methods to develop this algorithm. So the mathematics is something like this, which is the information we require to develop. That 1/10 of total bees go for searching the site. Information is shared by waggle dance. Decision is taken by consensus or quorum, and information to other bees through piping. which is not very commonly used in algorithm development, but yes, it is there in the nature. So how waggle dance give the information? Basically, how the bee judge the food quality, or pass the information. Okay, your food is at that place. What it does is it measures the angle of that particular food from its nest position with the help of the position of the sun. So with the help of the sun, what is the angle of that particular food source from the nest? This is how they evaluate the food position. So here you can see that this is the food position. This one is their nest. This one is here is sun, which is not visible. So from that, how much angle it is making, that is the angle they get the information. Okay. Second thing important is which few of the MIT people published also, that is a bee can remember only 4 places. It cannot remember more than that. So I try to use that aspect also in the algorithm, that how we can do it, that only 4 places can be remembered and we can solve some kind of a problem. And third target for me is I want to make it again derivative free, because I want to make it for global optimization problem. So okay, in this case, the distance, the position is calculated based upon the sun position and how much angle at that particular time the food is with the nest. So this information that we carry back, and then it make a dance like in that video clip you have seen. So when it make a dance like this dance, when it is dancing, the axis of the dance, the axis of 8 give you the indication of the angle basically. If it is 40 degree, then it will dance like this, and this angle, the sun to the food, it is 40. So the dance axis of the bee give the indication that what is the angle of the food from the nest. Is that clear? Okay, so this one is one aspect, that how that angle information is given. That is first thing. Second thing, how far it is, because angle can be infinite length long. So the number of encirclement of 8, how many times it encircle 8, that gives you the distance from the nest. Say if it is single loop, that means 1 meter. 2 loop means 2 meter. 3 loop is 3 meters. So this is how the V information is transferred. 2 things are there. What is the angle of axis? That is the angle of the food from the nest, and how much 8 encirclement is there, that gives the distance. This is how the information is transferred. So DBC is some assumptions are there which are taken in this algorithm. That is, they live in an environment. There is no any dye and nothing like that. We attempt to achieve particular goal. So all agents do that. So same with the bees also. Information exchange process is there is no any loss. Whereas in practical there is some loss of signals. But what we assumed, what the information they are passing to others, there is no loss of information, and they never die. So these are the 4 assumptions which I have taken to develop this algorithm. So now directed, why I call it directed, and what's the benefit? Say my problem is 1 dimension problem. Okay, what I have done is, this one is 1 dimension. This is my range from here to here, variable range. I divide this into some small segments. So I divide this whole search space into 1, 2, 3, 4, 5 regions, and I place in each block I place 1 bee. So what this bee has to search now? Only this much space, this much space. So the search space is reduced by the number of bees. That is one thing. Second thing, what this one is searching, this one is independent of this one. So all bees are independent of each other. So I can go for directly, I can go for parallel computing, because one is independent of each other. Okay. So if I put like this order, so I have 1, 2, 3, 4, 5 blocks, and I want to search this whole space, how much time I need? That is the time taken by 1b. So the time taken is 1/5 of the time taken by total, because otherwise what will happen? I have to search this whole space, and now I have to search only this space, and everybody is doing parallelly. That means the total time taken is 1/5. So time reduction is there. Okay, so that is one way. That's why I call this directed. Directed means I'm forcing every B in every block. So something like this. If it is 2 dimension, you can put it like this. If it is 3 dimension, you can put it like this. In a cube, only 1B. Okay, so otherwise it has to search whole cube, but now it is searching only a small cube, and all are doing parallelly. That means time taken by all is same, whereas the area is reduced by the number. So that is how we place the piece. Okay, so the mathematics is very simple. Now the thing is, next question is where to put it in that particular block. Should I put it at corner or where? I did some experiments. I'll show some results if they are there. The best point we find out, you put it at the center of the box. At the center of the box, you put it and let them do the search. You'll get a good results. So how to get it is simple. The initial point, end point by 2. So that is the location where I'm putting that particular B. This is how I put all the B's in all the boxes and ask the B's to search it. Okay. Then comes how they do the searching method. So because challenge is I have to limit it to only 4-point memory, and second I want to make it derivative free. Which method support it? I searched a lot, and then one of my scholar, he told that, sir, in 1949 or around 50 there was one algorithm which is used by researchers, that is geometry based algorithm known as Nendler's Mendel method, NM method, which is geometry based and which is 4-point based search method. So we use that method as a search based method. So what is that? That's simple. This one is the initial point of the B. It search here. Search means get a food value, that is objective function value. Search here, search here. Okay, if these two values are more than this, it calculates its midpoint and take a projection. If it is A, next projection like this. So this one is like expanding, moving, how it's moving. If it is, then it get search this point. So 1, 2, 3, 4, only 4-point search. You understand it in again. This one is initially where it's starting. Search this point, search this point. If these two are good, it calculate a midpoint, take its reflection. So it goes here, search here. If this is not good, then it come back half of the distance. So it goes like searching, expansion, contraction, expansion, contraction, and it's searching both of the space. This is how this. So there are four points. Start the motion in each solution. Extension. This one is extension. This one is contraction. And if there are bad solution, it's shrink. So this is the method which is very well known as Nendler's MAD method, used long back, also known as geometry based search method. We have used this method. Basically, I have used this method for my problem. Other variants of B colony, they have different kind of algorithms they are using. So this one is a sync. Okay, so this one is again the same explanation of the same thing. It's search, go expansion, go reduction, contraction, expansion, contraction. So it keep on searching like this. This is box. It there. It try to expand, search, then contract, then search, then contract, and likewise. Likewise the movement take place. Expansion means if the solution is good, it will leave this place. It comes this place. That is expanding. If it is not good, it go back to the initial point. The red means this one is bad solution. So it keep on leaving the bad solution, moving towards the green one, which is good solution. So this one is a view of one algorithm. It started from here, a triangle formation. You can see it keep on moving, and it finally reach to the best solution. So this one is the way how it do the searching mechanism in your B colony, directed B colony optimization. another way of doing the same thing. That is, it starts 1, 2, 3, 4 points, then next 4 points, then next 4 points, and finally reach to the solution. Okay, so when they do all these solutions, so each B, there are say I have sent 5 B's. Okay, now 5 B's are there, they come out with 5 solutions. So one way is, now there are two decision process. Either you go for consensus or quorum. Quorum means everybody agree. So what is the way? Get the minima of that one, so that everybody is agree on it. Second one is you put a threshold that anybody who's less than this threshold is acceptable. So we have two methods, one is consensus and another one is quorum based method. So those we have applied. So this one is just calculate the minimum of that one, that will give you the solution. Minimum is minimum of that value. One is 20, another one is 19.8. Obviously 19.8 is a solution for it. Then comes another case basically. And I and one of my student, we are working on it. This is another case. Let's say he jump out. Say, sir, if we have problem like a sinusoidal waveform where we have multiple maximas or multiple minimas of same value, so how to address that one? So this is the story here. Then we put a framework which appears first. You cannot make, you have to make some kind of rules. So like all these are same values, all these are maximas, or all these are minimas, but which appears in the range first appearance, we call it that okay, this is the solution. Otherwise it keep on repeating and repeating, it will not lead to any kind of solution. So that we put it if the solutions are such kind of solutions are there. This I already talked about, these two methods. So that there is an algorithm in front of you. I think it's not very clear. This one is what you have to do is define your objective function, that you can define your how many variants are there, what is lower bound, what is upper bound, how much size, step size means how much you want this search space to be measured or to be searched by 2 B's, so 50-50, 3 B's, 1/3, 1/3, 1/3, 5 B's likewise. So how much step you want, and accordingly the number of B's, and then the start process basically. What is the starting point? The starting point is middle of that particular block. That is the starting point. No any much mathematics in it. And then method, you can take a two loop. Either you go by quorum based method or you go by consensus based method. In this method, consensus based method, there is no any problem. You have solution, find out the minima, you come out and stop. In quorum based, you have to check it, that those who are passing the threshold, how many are there and how much band you are allowing for it. Both have their advantage and disadvantage. I will show you the results, which one is better and how. And that's all in the algorithm itself. Oh, this slide. These are CEC problems basically. In the morning I talk about some kind of benchmark problems. All these are benchmark problems. So these are benchmark or simple benchmark, then shifted benchmark, rotated benchmark. There are around 30 such problems. Their names are there are different names given to them. They like camel function, Rosenbrock function, likewise. So there are so many functions. Around 30 functions are there, which cover almost all kind of optimization problems. So these are CEC benchmark problems. It is given. It is well defined. These functions and these values are well defined. That these are the range, these are the dimensions, and these are the minima and maxima possible. People are still searching out what is the best solution, but these are the things which are given there. So then we perform various experiments to justify our hypothesis and our algorithm. So if you take this one, this first test we have done to compare the decision between consensus and quorum based. You can see the one experiment was done on banana function whose value is 0, optimal value. Consensus is reaching 0, but the time taken is 1.399 seconds. This point, all the experiments have been done on the same machine. It's not like we are varying the machine so that there is some variation. Everything was done on same machine. Whereas in quorum based, if I put a threshold 10, the optimal solution reach in 0.19 seconds. But if allow allow the increase the threshold, you can see the value 0 is reached, but the time is almost same. So now the decision making from here, you can see you can take a decision whether you want to go for this and this on the basis of only one thing. If you need a accuracy, you can go for consensus, but it will take more time. And if you have a space that okay, I'll allow this much of error, go by quorum because it is faster. Say if I can allow the error of e raised to the power minus 009, the time is almost 1/20th of the first one. So it depends upon you that what is your preference. You are going for accuracy or you are going for a time. Depending upon that, you can choose whether should I go for this way of decision or should I go for this way of decision. Again, experiment was done. How many number of bees basically? So we have implemented on the same objective function different number of bees, that how much good solutions they are producing. We have seen that B is somewhere around 50 is giving good result, but it is very dominating when we have B's around 400 or 450 or something like that. But around 100 we are getting also around 160 or 170 number of B's, we are getting even good results. It's a simple, like it's a grid computing kind of thing, you can say. I break whole area in a grid. So smaller is the grid, smaller is the search area, better is the solution basically. But again, then it needs more space. If you have a computing facility, you have 100 computers, then it's very fast. You divide your problem into 100 segments, send each segment to each computer, calculate and take it back. So that is basically to check it out how it performing. Then I compared this one with other benchmark problems to prove my algorithm whether it's good or not. So here are the functions like sphere, Rosenbrock, rotated, hyper, squall, restring, Ackley. These are the functions and these are the algorithms. Genetic algorithm, evolutionary, particle swarm, bacterial foraging, harmony search, differential evolution, artificial bee colony, and this one is DBC. This is what I proposed. And the interesting part, when I compared with these one, there are two things. This one is mean value and this one is the standard deviation. What I found is this algorithm is having a good solution in terms of two things. It is reaching to the best solution. Second thing, this one is giving a unique solution. In all other methods, what we are get like GA or PSO, differential evolution, every time you run, you'll get a different answer. Whereas in this algorithm, you run it 100 times or 1000 times, every time you will get a unique solution. Reason, very simple. Initial position is fixed. We have initialized the things. So we have what I have done here is I used deterministic and heuristic, both methods I have combined, and that's why this one is giving a unique solution. And since this one is giving a unique solution, it is most suited for your real-time applications. So I tested on this one with a simple 2-dimension problem, and then check with another multiple dimensions, and then I perform t-test. T-test is used to check it out whether I'm good than the other or not. You are aware of it. Those who are in research, they know stat methods. So I found that this method is performing good in most of the problems than the others. Then I increase the dimension. Basically, I want to see that whether if I increase the problem complexity or dimensions, if I increase, whether still it is good or not. So I increase it from 22 to 30. Now it's for 30 dimension problem. I checked and compared with other algorithms and found that yes, it is still performing better. And then applied on CEC 2005 benchmark, where they have all problem which is shifted, rotated, and hybrid also. Earlier it is not shifted or shifted rotated. Now it is shifted also. So like initially minimize here, it is shifted, and then it is rotated. So you don't know where is the minimum. So these are more complex problems. So 2005 and the results, though it's not very clear in this screenshot, but you can download the paper The paper is directed B colony optimization. That is available on elsewhere. These results are there in that. So what are the upshot of this one, conclusions of this one? That this one has two things which are very good. One, this gives a better solution than many of the existing algorithms, and the main thing is this algorithm gives a unique solution. Always you run, you will get a unique solution. So there is nothing like a standard deviation or something like that, because the solution is unique. So this one is most suited for your real world problem. Other classes can be added. I have written there. You can compare this algorithm with these other algorithms. I haven't done so, but you can do it. So that's about the development of this B algorithm, which is known as directed B colony optimization. Yeah, any question on this? There's a difference. There is randomness in the search. There's a randomness in the information transfer. I kill that. I make it a hybrid with the deterministic approach. Can we kill the randomness and still we can get a good solution? So that is basically a target. So we kill the randomness also, and still we are getting good solution. So that is the main point of research here in this this.
Here the main difference is the algorithm only, the algorithm.
Yeah, that one, and the how we divide the region in ABC. There is no any division of region. Basically, they do randomly search throughout the space. Here we have forced them. Okay, you do the search only in this region. So that's why it's faster also. If I compare it this one with ABC, this one is faster, because in ABC they are doing randomly search and they are searching whole space. Whereas I'm also searching whole space, but I'm dividing into grid and searching only the small segment. So the number of the segment, if I increase the number of the segment, the time will reduce by that factor. One is time taken by 1, another one is after using by 10. It will be 1/10 or something like that.
Hello. Good afternoon, sir.
Yes,
Sir,
please.
in this DBC algorithm,
Mhm.
how is it assured that it may not skip the global minima or maximum?
Okay. How we assure in genetic algorithm whether this one is this one is in local or global?
Please, sir, that is the disadvantage of GA, that it traps in the local minima.
Okay. How we ensure in PSO? We cannot assure in any of these. They are the mathematicians. They are trying to prove it that okay, they will. This is the proof that okay, they will not. One can say not trap in local minima. Well, in this case, I can say, because what I am doing is I'm breaking the whole space into some grids, and when you put the grids, your global solution become a local solution. I think you agree on it.
Yes, sir.
So now local solution is easy to find out.
Sir, the picture means the slide I saw. In
Mhm.
that, it is based on the contraction and expansion.
Yes.
If there is any, I mean, step size in other algorithms where we see that there is a step size also is there.
Step size.
Any, yeah, anything related to step size is also there in this algorithm.
Yeah. So see, my problem. You can take it from this graph. I have this one simple problem. Okay. I think can you see it, no?
Yes, sir.
Okay. Now this one is local, and this one is global. I put it G. I put it L. Okay. Now if I what I am doing in most of the algorithms, what I am doing is randomly I am throwing particles in whole this region, and they are giving me solutions. Okay.
Yes, sir.
And then I move these places, either these or these, to reach out the solutions. This is what all algorithms are doing, whether it's PSO or GA or DE or whatever you name it. Instead of that, what I am doing is I divide it into grid, and I'm putting elements, fixed elements everywhere. Fine.
Fine, sir.
Okay. Now for this B, this one is the solution, which is local. And for this B, this is the solution which is also local. I compare and directly come out to the solution, which is very fast and which is unique, and I can ensure which is global also.
So after each iteration, these are compared.
Huh?
After each iteration, we
Yes.
are compare.
Yes. After every iterations, we are comparing.
Okay. Thank you, sir.
Any another? No questions? Okay, fine. Now I'll close this algorithm. I'll talk another one. This one is basically, this one is very interesting. We started watching when in my lab I was watching an animation movie with my grad students. That is known as B. एक movie आया था बच्चों का. And from there we inspired. Okay, they have explained this theory in their animation movie. And let me share with you this algorithm. Me and my undergrad student, we developed it. There's no any big research scholar team who worked on it, but this algorithm is working very fine till so far. I don't know, next researchers they modify it, but till so far this one is working very fine. Okay, some more interesting algorithm I want to share with you. Okay, that is basically watch. If go by songs also, but you watch this video, which is very interesting video. I have taken it from National Geographic. Sound नहीं है? इसको नीचे करना पड़ेगा. There is no sound.
Don't be intimidated. Don't let the gray wolves.
Okay, I start this video and watch the video carefully, because this will help in understanding the working and behavior of wolves. And people have developed an algorithm that is known as WFO, gray wolf optimization technique. Okay, so let's observe the behavior. We have tested some new variants on it.
We're here in Yellowstone National Park to follow some gray wolves and observe the deadly brilliance of the pack. They've learned to cooperate, hunting their prey with many acting as one pack. This mother grizzly knows how to protect its cub and itself. Stand your ground. Don't be intimidated. Don't let the gray wolves run you down. Grizzly mom stands up to the gray wolves. And eventually, they lose interest. Stand up. Hold your ground. Wolves know that large prey can be dangerous if they fight back. What the wolves want is to get their prey on the run. Like, for example, this herd of elk. Now the wolves can fan out over the herd, waiting for an old, or sick, or just unlucky elk to make a wrong move. The alpha male leads the hunt. He bides his time, directing his troops. And eventually, one elk stumbles. The hungry wolves quickly surround the faltering victim. They swarm in for the kill. And then, the meal. Wolves are a vital part of a healthy Yellowstone ecosystem.
Do the hunting. From there, we worked on another algorithm, which is known as gray wolf optimization algorithm. And this algorithm is uh, developed initially by the researchers, and then some modifications comes in. So we'll understand how the things happening in the nature, and then how you can convert those good points to develop your algorithm. Okay, so outline for this presentation was about gray wolf, and then developers of the algorithm, how it work in nature, and how algorithm is developed, and then example, and what are the advantages of other techniques, and one application on unit commitment problem, which is very common problem in electrical engineering. So basically, they are characterized by the power of their teeth, and the group size is around 5 to 12. So now swarm size is not a problem because it is already written there, it is 5 to 12, very small number is there. Okay, their natural habitats are mountains, and their name biological is Canis lupus, and they are the top of your food chain table. Basically, they are the most one can say, most powerful one. They can eat anything basically, whatever it is. The food chain, they are at the top of the food chain. Look like that, how it is there. So let's understand how they work, and then we develop go for our algorithm. These are the people who worked or this one to develop this algorithm known as gray wolf algorithm. So if you hear that movie, he talked about alpha wolf, beta wolf, or something like that. So there is a hierarchy in this one. There is alpha at the top, beta, delta, and gamma. Alpha is the leader basically. Okay, and then beta follow alpha, delta follow beta, and gamma follow everybody. So it's like a king kind of hierarchy. King is there, and then advisor 1, advisor 2, and then the whole crowd is there. So the same thing is there. So alpha is a leader and decision maker. Beta and delta, they assist alpha in decision making. So you can say alpha is a king, and then the king is having 2 advisors basically. So that is beta and delta, and rest are the followers basically. So this is how they have, and they work that way only in nature. Okay, so hunting behavior is very interesting. They track, they chase, they approach the prey, they pursue, they encircle, they harass, and then they attack them. So first they find out which is the prey, which is probable prey. Can you kill it or not? They try to find out old, weak, female, something like that. Okay, this one can be attacked. So that one is they track, they chase, and they approach. Then they perform 3 kind of things. They pursue, they do the encircling, and they do the harassing of that. And finally, when that subject is tired, then they attack, and then they, because they themselves are very small in size and power, but they attack, they go for big animals and like. So what is this one? This is showing your approach, track, and pursue. So there are the 3 alpha, beta, and gamma, which are there. 3 different colors, and the prey is there. Rest, they are just watching how those 3 are doing. So initiation is taken by alpha with the information from beta and delta, and gamma, they are waiting for the signal what to do. So this one is the first, they approach, they track, and they pursue. Second one is, this one is pursuit from all sides. They try to capture it so that the movement of the prey is restricted. Okay, so this one is something like food source. They are try to cover the food source from all the sides to find out what is the best food source. something like that. Then they harass basically. Harass means from every side, from this side one attack, then they stop. That is just supposed to attack but not attacking. Then from the second side, from the second, third side, they keep on harassing that person basically, harassing that prey which is here. So they are harassing from all the sides, and then they do the encirclement from all the sides, and then they sit down. All are waiting. This one is also tired. They are waiting how much more time it will take to lose its energy. And once they see that now its energy is gone, they attack and eat. So all these processes are there. So this is how they do it, and let's convert this approach to an algorithm basically. Let's see how it works. So in order to mathematically model, we have to consider fittest solution as alpha, because that is the leader, that is more fit. Consequently, the second and third best solutions are beta and delta. The rest of the candidate solutions are taken as omega. And in GW algorithm, hunting is guided by alpha, beta, and delta. Omega walls follow these three walls. So what I will do is, initially, randomly I put some values, find out the solution, and then I assign alpha is the best solution, next best beta, next best is gamma, and sorry, delta, and the rest are omegas. And this is how we start that one. So if you encircling is if you watch this figure, this much is almost same as your directed B kind of structure. Okay, so here the encirclement is there, and this one is food. So this position plus some delta is this position. If this one is my position as a alpha position, I can find out what is this position. So X star, Y star is the food position. Okay, XY is my position, and these are the possible other positions. This one is in a circle. This one is in a cubical shape. It can be in n dimension space. So I know where is X star and Y star, and I know where I am basically. So this one is how I can mimic the encirclement in algorithm side. So how to do that? No? Encircling means what I'm doing is, many of you are aware of it. The mathematical model of encircling behavior is represented by Cpx minus Ext. Isn't it is a distance? It's a distance equation. So I calculate my current position in the food position, or how much is the distance. So that factor I use to calculate the movements basically. Okay, encircling since this one is area, so we calculate some variables A and C. These are the two coefficients. One is 2R2, another one is 2R1, RA. I'll show with example how to choose these variables and what it means. T is the current iteration, X is the position. If you go by this one, T is the current, X is the position here, and R1, R2 are the random vectors, R1 here and R2, and linearly varies from 2 to 0. So initially it is 2, then it goes to 0, and description I'll show you here in the slides. Well, hunting we have discussed, so I'm not explaining this one. I'm coming to the mathematical part. I think to equation 5, that is nothing but a distance equation. Distance between, what distances I'm calculating. I'm here, food is here, how much is the distance? First, alpha, here is beta, how much is distance between alpha and beta? Beta and delta, how much is the distance between beta and delta, and beta and alpha? Omegas I am not interested. So that is what I am calculating, and then I am calculating the average of the three, x1, x2, x3 by 3. So that is what exactly I am doing, and then random numbers I am using to calculate A and C. Mathematically I will show you with an example also. So this is what exactly happening here. This one is alpha, this one is your beta, this one is your delta, and this one is the position of prey. So they are calculating the distance between them and the distance between this and this, and also this A and C, they give their radius, how much area I'll take to attack basically. So is that in my region or not? Finally they have to converge. I'll show you the figure calculations here. If A is less than 1, mathematical proofing is there. I'm not going to the mathematical proofing of it. If A is less than 1, that means this move towards the prey. And if A is greater than 1 in calculation, that means it is going away from the prey. So we have to put the variables in such a way that a mode of A has to be less than 1, so that it keep on approaching this prey. Let's solve it by example. That minimization of Korn function, which is given by minimum of x1 minus 5 square plus x2 minus 2 square. Let's do it. These two are random value, can be anything. Okay, and I have taken 12 values because the number of walls is 5 to 12. So 12 walls here, or 12 agents, or 12 swarms, or 12 bees, or 12 parents, whatever you want to imagine that is there. That is 12 basically. These are random. And then I put these values in this function. Find out what is the function value. Since it is a minimization problem, so best solution is this one. So this one will be my alpha. Next best is this one. This one is my beta. And next best is this one. This one is my delta. So I assign alpha, beta, and delta from this solution. Is that clear till so far? It's very easy. Then I calculate the distances between alpha and the everyone, alpha and the food, and alpha and beta, and likewise. See, you can assume any random number, 4.7372. It's a alpha x1 minus 6.16. So first number. So I'm calculating that distance. What is the distance between this one and this one? That is d alpha, d beta, d delta. I calculate the three distances. Take the average of those. Those I have here. A can be taken by this method, iterations. This one you can vary how many iterations, first iteration, and then now you substitute in these calculations. Sorry. So you modify it. You modify the new values. You modify. See, where is the change occurring? I'll show you. Sorry. X1 is 6.1686, 4.4100, and 7. So you just remember this slide. 7, 5, 46, and there is 1, 2, 2.9. After doing all these changes, your x1 is varied. How x1 is varied? I have calculated x values. So by that amount, that x1 moves towards alpha, because omega has to follow where is the leader base. So that's why this value 6.1686, this is the difference. So the new value calculated is 4.0487. So 4.0487. So for all values, these values are calculated. And now again calculate fx. And once again you calculate fx, and you will find the alpha is new. There is new alpha, new beta, and new gamma. And every iteration it keep on repeating. The process remains same. Is it clear? No. Let's make it more simple. 12 लोगों ने अटैक किया, अपनी पोजीशन हमको पता है, उसमें से हमने मान लिया कि ये अल्फा है, ये बीटा है, ये कर्व है, ठीक है। उन तीनों के डिस्टेंस, अब मेरे को किधर जाना है, मैं ओमेगा वाला हूँ, मैं अपना डिस्टेंस तीनों से निकाल लिया, उनकी मीन वैल्यू निकाल ली, उस मीन वैल्यू पे मैं चला गया, ठीक है। सभी जाएंगे, केवल अल्फा वो नहीं जाएंगे। तो नए सेट आ गया, वैल्यूज पोजीशन चेंज हो गया, नया सेट आ गया, नए सेट पे दोबारा से इवैल्यूएट करूंगा, उनमें जो सबसे अच्छा होगा वो अल्फा बन जाएगा, जो बेकार होगा बीटा, उससे बेकार होगा, फिर वही कैलकुलेशंस करूंगा। This one is much simpler than your other algorithms, and the solutions are very good for this. The flowchart is okay. So it is very easy. Convergence is faster because continuous reduction in the search space. Every time your search space is reducing, there is no any chance that search space increases, because I have to make A conditionally less than 1 so it always converges. There is no chance that it will go expansion kind of structures. And there are only two parameters to be adjusted, A and C, that once you do it, you come more on it. Unit commitment problem is there, so I'll explain on this one just to share the results which we have published, that is economic load dispatch, but converting to UC problem. And unit commitment problem is a complex nonlinear mixed integer combinatorial optimization problem. So it has a combination of many. It is a nonlinear problem, it is a mixed integer, it is a combinatorial problem, whereas variables are presented in terms of 1 and 0. Unit commitment means either this thing is on or it is off. Okay, so I have to give some supply. So which unit has to be on or which has to be off? There is nothing like 50% off, nothing like that. Either it's on and it's off. It's a combinatorial problem. So we have implemented, and we found that with different units, if there are 10 units, 20 units, because more units, it's become more. So CPU time, just to check out the complexity studies on the algorithm, and then we compare it with these methods, and we found that this algorithm is better than the rest. In many cases, most of the cases, it is better than your Lagrangian, genetic, EP, MA. These are the various algorithms. PSO, integer, modified PSO, fireworks algorithm, and Gray Wolf algorithm. So here the Gray Wolf algorithm perform better than the rest of them. Finally, this one is published in some journal. So this is about your Gray Wolf algorithm. So basically, the aspect is, if you in the broader sense, they are almost same. In PS also we are doing the same. In PS, so everybody is searching, talking, moving, and all that. But every time we are calculating G best and all these things, and then working in that way. Here the things are restricted. Information I have to now. Every particle is not taking. Every particle is just watching the only one value, which is calculated by the three persons. The value which is calculated by alpha, beta, and delta. Based upon that value, they take the movement decision. Whereas in PSO, I have my personal and I have global and all these things. So the things are changing a bit, and interesting part is how you are mimicking the behavior of the animals and humans to your computer program or computational program. That is the main thing. So this one is GWA, which is relatively very new. I think most of publications are in 2015 or 14. This one is a relatively new algorithm. Any question now on GWO?
Here also you did the programming on normal programming language.
Yeah, mostly now we are working on Python. We are not working on MATLAB and all these things, because this one and this also doesn't need much of the things. Only 4-line or 5-line coding is required. I have to just give random numbers and then arrange them in your ranking order. First rank is alpha, second rank is beta, third rank is delta, rest are omega. Calculate the distance between them, take the mean value and modify their position. Again, rearrange them in the ranking order, and the things keep on repeating. Any question? No. I think it's very easy. There's no any question on it. So should I talk more, because I have a large variety of algorithms, or should I stop it here? Okay, music. Okay, let's enjoy the music at the end of the day. Okay, I want you to listen the music, and then from that music we conclude few things, and then we develop one algorithm which is known as harmony search algorithm, which is developed by Professor Gein. That is HS, harmony search algorithm. Okay, so let's listen some music, and then let's try to conclude something from there. इसका ये ऑन है ना? very first note, okay, like this. Only this much is give me a hint what is the source. Peculiar point or peculiar thing which we remember throughout our life. There are many songs which we do not remember even we heard yesterday evening or even today morning also. So let's take out these points and then we develop the algorithm. Okay. Yeah, अभी कुछ और सुनाना है. So from the first song we have second I can have few with me. Yeah, you listen to the songs. आप देखते भी रहिएगा, उसके ऊपर लिखा हुआ भी आ जाएगा. First song and second, there is a okay, so we check it from there. I put a copy tag. I don't put it. It's from taken from YouTube. One song from the movie Rocky. This one is a Hollywood movie. Three notes. Okay. चलने इसको और चलने दो और गाने सुन लेते हैं थोड़ा अच्छा लगेगा. महबूबा महबूबा well-known song. Okay, listen the music of महबूबा महबूबा marriage part. महबूबा गुलशन में गुल खिलते हैं जब सहरा में मिलते हैं, गुलशन में गुल खिलते हैं जब सहरा में मिलते हैं. मैं और महबूबा 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 गुलशन में गुल खिलते हैं जब सहरा. All the things you're telling me, I never heard you say. Oh, the tender words I'm living for that you may say today. It is melodious in one language, and if you play near around it in another language, it's again melodious. Okay, and yes, many of Indian musicians they do it. This one is sorry, this one is your R.D. Burman. R.D. Burman is well known for. There are so many. Okay, so I'm closing this. So what we can conclude from here is, if anything is good in this one, if I create some frequency or pitch near around it, it remains melodious basically, and people love it basically. Okay, so that is second thing which I want to show you. Third one, mine off करते हैं. So third one is you just watch this one. Okay, just listen the music and enjoy the music, and then we conclude something. Please. Okay, every time I have to do that.
When you speak, you
फिर मोहब्बत करने चला है तू यही रुक जा जरा फिर मोहब्बत करने चला है तू इस जाने सभी के लिए किसी ना किसी को है बनाया किसी के लिए कुछ तो है तुझसे
Anything interesting in this verse? Anything interesting? In this short time, he shifted from one song to another song to third song, and almost on the same track kind of structures. Okay, so where he's playing, basically he's playing with the pitch. He's just moving on the same note, bringing those scales down, bring this scale up, moving and smoothly shifting from one scale to another scale. So this one is the third observation we can have. Okay, and these three things will help in developing a algorithm that is known as harmony search algorithm. So scaling we can play with. So how the musician prepare develop the music and how they use it for their part, but Professor Geem, he used these algorithms to develop this algorithm. So I'm using his own presentation to explain your harmony search algorithm. So this one was Professor Geem presentation. So all thanks to him. You can download many of the papers, code, and this presentation from his website. The website is Harmony Search Algorithm. It's freely available. Anybody can download all these things from there. So optimization we talk about, and there are different problems we talk about, and these are the different algorithms which help us in a different way. Genetic means survival for the fittest. Memetic is a combination of these things. Swarms, particle swarms, and then bee colony, which works on the bees behavior, and likewise. So he shifted from this one to a music one, and let's take about music algorithm. So I'll explain this one. So this one is basically inspired from the music, and inspired how the musicians they prepare music. So there can be three things. Okay, one is you take somebody else's music and put your words to it. Okay, that is one. Second, you take somebody else's music, change a bit. Third, you take your own already hit line or your own already hit music, create some changes. Like if you you could very easily tell that this one is A.R. Rahman music if you talk about 10 years back, because he has a particular kind of pattern. And once that he just throw one music, if it is hit, the next music or next song is near around that one. Like if I talk about R.D. Burman, he is known for guitar. He use a lot of guitars and all that. Similarly, he use a lot of people use a lot of some old musicians. They use a lot of tabla and likewise. So they have some kind of hit already hit songs. So they just play near around it. Third one is you come out with a totally new thing. Like A.R. Rahman when jumped in is totally new with a totally new concepts. So there are only 3 or 4 ways by which you can compose a music. And which music stay for a long period? Which is melodious. So now the things are okay with us. To optimization algorithm or computer engineer, melody means optimal solution. Okay, tracks means my variables, possible solutions, and creating a change in those tracks means creating a change in the variable to get the best melody. This is exactly what is harmony search algorithm. Okay, so we coming to that, this figure, because they don't talk about saregama, they have do re mi, something like that. So for that do re mi, so this first instrument is do, second is mi, third one is so this combination makes some kind of sound, and which the sound must be melodious, that is objective. On the other side, bottom side, there are do means my x variable x1, mi means my x2 variable, sol means x3 variable. I've taken 100, 300, 500 and put it in the function and find out the value. If this value is very good and I'm solving maxima problem, that means it's melodious. If this value is less and if it's minima problem, that means it's melodious, otherwise it's not melodious. So that's the analogy. So there, like we have saregama pa, those are the variable values. Number of the instruments, I'm using 4 instruments, 5 instruments, those are my variables. So how instruments I'm using and what values I'm taking, that is basically the job in your harmony search algorithm. So these are the factors. Okay, let's check it. Music instrument means decision variables, x1, x2, x3, x4. Pitch range means value range, x can be this to this. Pitch means how much it go up, how much it go down, so that means how much is the value of my x1. Harmony means solution vector. Aesthetics means objective function, how melodious it is. And practice means iterations. More you practice, more iterations, you'll get a better solution. So that is basically analogy between music and your mathematical algorithm. And experience means memory matrix. Because sometimes I choose the things from my experience. Okay, for this time, this part, this note is good. So that is basically memory matrix. So this one is good and bad memory. I'm skipping this one. So what are the steps now? So this is how they prepare music. Those who are having interest in developing music, you can use these steps to prepare music, or you can use it to solve your engineering problem from these steps. So prepare a harmony memory means 5 or 6 different combinations. Okay, I'll go by sa re, I'll go for sa re, I'll go for sa re, means you can have a different combination. So you just prepare a harmony memory. Okay, improvise a new memory with the experience. Randomness, maybe gradient, through randomness, not through gradient. So you increase or decrease those values. Which values? There are rules how to increase and decrease. Once you are okay with that one, then check the solution. If it is better than the previous, include it in the memory and discard the worst. And if it is not better than the previous, either you throw it or create a change and just repeat it. This is harmony search algorithm. Nothing more than that. Okay, let's see it through an example. So how these operators can work? Either I go by randomly playing the things, or I consider my memory, what is there. I consider it, okay, this one was good, let's move it a bit better near around to it. Or I can adjust the pitch, or ensemble consideration is in the frequency domain, how I can view it. And resonance, so these 4 and 5, they are just how it is appearing at the end. It is going for smoother variation or it is going in the bad variation. Not going to this, I'll show with an example, because these symbols right now it's difficult. Let's solve this problem using a harmony search algorithm. You have to minimize x1 minus 2 square plus x2 minus 3 to the power 4 plus x3 minus 1 square plus 3. We know, yes, the solution is 2, 3 and 1. That is for our information. But I want to solve this problem. So what is the way? Minimization is the problem. Randomly choose x1, x2 and x3. Okay, so this one means this one is one instrument, this one is another instrument, and this one is the third instrument. So randomly I taken one one combination, second combination, and third combination, and put these values here. So find out the what are the function values, and then they arrange them in the rank side. This one is the best at present. This one is next best. This one is the next best. This one is the first step. Okay, then we can choose the values from this one. Values from, for this instrument, what is the, now there are three ways to do. One is I just observe what is the best value which suits. Second one is I choose near around the best. Third, I choose randomly. So though I apply all the three conditions here. This one is the minimum in this one, so I choose this one. This one is, these two are tie, near around, I choose it. In this case, randomly I pick it because neither it's minimum nor it's maximum. Just I take these three values, 1, 2, and 3. Once you do it, you'll find that when you choose these values, choosing these values means, choosing these values means choosing the values from my memory, already existing memory. Okay, there are other operators which are to be used while how to choose the memory or not. There are certain formulas, but I'm talking about the basic H's. Okay, so from the memory, if I have taken a combination 1, 2, and 3, so then I put these values here, 1, 2, and 3, and calculate the function value. So I'll see that 1, 2, 3 is 9. So which is out? 16, because that is maximum. So that is out. So this remains there. So now the sequence will be 4, 9, and 30. Again, you apply this kind of pattern and keep on playing with the pattern. Finally, you will find that solutions are converging and they are reaching to the best solution. Similarly, anything I'm playing here. Here now, this time I'm not going for the minimum because there are two. I go for the near around minimum. So I go for here. Here I have taken, they are same. I go for this one. Here I have gone for the minima. So now the solution is 2, 3, 1. I put it there. Again solve it. I'll find that 2, 3, 1 is not good one or better one. So I keep on modifying these things till I'll get the best solution. So you keep on doing all these things, creating a change. Say here what I have done, created a change. Change means the value is already there. Say 2 is already there. What I can do maximum to it, 2. Either I increase 2 or I can decrease 2. Amount you can decide. So I can do one thing. I can increase this value by a factor 1. So this I have taken as it is. This I have increased or decreased by a factor, and for this I have taken any random value. So now my values are 1, 4, 2. I substitute in this one, the solution becomes 6. So there can be and different tools depending upon how you want to use this algorithm. One way is this one. Another way is you can go totally random. Totally random is not a good idea because it may converge or may not converge. So some section random, some section near around the already known solutions, and someone is the best one. So all the three combinations are incorporated. Totally new song, that is this one, totally new. This one, existing song, creating small change up and down. And this one is already best song already. We know this song is melodious, so I'm taking as it is, and then I'm combining those things and come out with a new solution 6. So 6 is better than, obviously this will be out, it comes in, or it is better than even 9 also. So 13 is also out. So we have solution 4, 6, and 9. Then you again apply this thing, and then 9 is also out, then 6 is also out. Keep on converging and give you the best solution. This is nothing but this is harmony search algorithm. You can use it for any purpose. Even some of the composers, music composers, they have used it to get the best melodious sound. So from musicians we learn, and from our algorithm then they rebuild the things. So this is how engineering works. So this is there are a lot of applications. इसमें figures नहीं आ रहा है. One is this one, multimodal functions, designing of XOR gate, real world problems, solving a Sudoku problem. It's damn difficult. If you are interested, I can pass you some problems which are still to be solvable. Okay, solving composing a music, they have done it. How to compose a music by using a harmony search algorithm. Project scheduling, you have 18 or 19 different aspects which has to be placed where. Or timetable scheduling, which is a very big task in universities, or residence scheduling in hospitals. Timetable scheduling is a very difficult task. It's not so easy. People say, okay, we can do it, but satisfying 150 or 200 faculty with the message, otherwise congestion will be there. So congestion management, whether it's a internet or wireless network, or whether it's a traffic management in civil engineering. Okay, parameter calibration, trust design in structure engineering, school bus routing problem. This one is again a routing kind of a problem. Okay, this one is your generalized orienting problem, that we have to plan some kind of a city or some kind of center somewhere. What is the best location so that these things are not disturbed or they are fulfilled, something like that. A water distribution problem in civil engineering, that there is so much had to be maintained, so much area to be covered. So what is the best way to channelize the water? A large scale water problem, multiple dam operation, hydraulic parameter calibration, ecological conservation, satellite heat pipe design. Lot and lot of problems are there which they have implemented. So these are RNA structure prediction, bioinformatics. I don't know, somebody is there in bioinformatics. It's a very typical problem. What will be the structure of RNA? So it's an optimization problem, because the objective function here to fulfill is the minimization of the energy. Everybody knows that things are stable when they are in minimum energy zone. So what is the minimum energy obtained? So what is the RNA structure? Medical imaging, location of a tumor, sizing of a tumor. Radiology, oncology, what is the how to reduce the effect of X-rays when somebody is exposed to that one, so that we can maximize the impact and and reduce the effect on the side organs. Oncology and robotics, visual tracking, internet. So these are the areas where people have worked, and this one is the site harmonysearch.info, from where you can download all these things. We have created, me and one of my students, we have created a new variant to it, that is improvised. When that one is intelligent tuned harmony search, because in this I haven't discussed what are the parameters to be taken care, but there are parameters. But if parameters are there, then what is the best value of those parameters? So we have designed a new variant of this one, that is known as intelligent tuned harmony search algorithm. You can download that paper for your reference also. So this is all about your music inspired optimization algorithm. Any query on it? You are most welcome. Yes, please. Questions on this music inspired algorithm? Yes, please. No questions? Well, thank you. Thank you very much. Yeah, no questions from the center. I think they got each and everything.
You also don't have any questions? But I have a question. How will you decide which algorithm you have to use?
It's a $1 million question. It's a $1 million question.
See, there are so many algorithms nowadays.
Few classification people have already made. That I have shown that if your problem is of this kind, variables are of this kind, and constraints are of this kind, then this algorithm is good. So that
there are literature on that also.
There is literature on that, and rest people keep on searching this. Yeah, whether this one is performing good or not. That is the only
So any questions, please? Any questions from the centers?
Yes, ma'am. From MMEC Mulana.
Yes.
Thank you very much, sir. It's a very wide knowledge about the various algorithms, and we have learned so many techniques at a single stretch of time. Sir, we would like to know the comparison of the on performance issues of various algorithms. Like which one is the best algorithm so far?
So if your question is that, then I'll say my algorithm is better than the others. Okay.
Got it, sir.
Because if you see the literature, now people have compared these algorithms on standard benchmark problems. So that will give you an indication that which algorithm is better in which case. So if you say search some new paper, say if you search a paper on DBC, I have compared around 10-20 different algorithms on around 20 different problems, and there's indication that where I'm standing. Similarly, somebody who has developed Gray Wolf, certainly he has published some article on the comparison of his algorithm with other algorithms. So that is the only way to understand to check it that which one is good or which one is bad.
Thank you very much, and we are looking forward for a book by you on these algorithms.
Yeah,
Best wishes for that, sir.
Let me get more older than for right now, and then I'll write sitting at home.
Thank you, sir. Thank you so much.
Actually, that's a good idea. There are no books on these optimization algorithms and any of these particle swarm optimization and other. You can try of think of writing a book on that. Okay, good suggestion. Anyone else? Any other centers? PVP Siddhartha?
Okay, no queries, ma'am.
How did you find the lecture?
Okay, ma'am, it's very useful, ma'am. All our participants are very happy with this session, and so many participants. Morning session, it's very good. Afternoon, it's also very good. We have learned many unknown algorithms to us in the afternoon session, and it's a really very good session, ma'am.
Okay, thank you. Thank you. DIT University? Hello?
Hello? Hello? No questions from this side, ma'am. Ma'am, actually we had a connection problem for this last session, during this last session.
Otherwise, morning session you have attended?
Yes, ma'am.
Morning session also was good only.
Yeah, we did ask that time all the queries related to GA and PSO.
Okay. Okay. MC Saxena, Lucknow? No one is there. No, they are there. Which college? MC Saxena? ये कौन है? Gandhi Academy?
Yes, ma'am.
Any questions?
There is no queries, ma'am. Thank you for the lecture.
How did you find the lecture?
Very good.
Okay, thank you very much. और कौन सा सेंटर है? Sukhmani Institute? Any questions?
Hello.
Yes, I can hear you.
Good afternoon, ma'am.
Yes.
Ma'am, there is no question from our side, but I really thankful to you, sir. He has explained means the queries which we have asked very well and in a very explained manner. And
Thank you.
sir has a great and enriched knowledge, and I also suggest sir to write a book on these algorithms.
Okay. He has taken your suggestion. I think first time you are getting a suggestion like that to write a book. Okay. Okay. Thank you very much.
Thank you.
So I also thank you so much for sparing your time, sparing your time here, and giving us an enlarged vision of different optimization algorithm which we have not heard at all till now. Harmony search and all. We have only read the names, how it works. We were not knowing. Thank you so much. Thank you for the time you have made. And I think you can see it in Google Hangout or YouTube afterwards also. If you want to see how you performed, you can also watch it because it will be there in the system. And any one of you who have missed the class because you had connection problem, you can watch it in Google Hangout and in YouTube afterwards also, evening also. So there is no problem that you don't feel bad that you had connection problem and you could not listen it. In the evening with the internet also you can watch it. There is no problem. So I request all of you, we can break for the day. Tomorrow we will have some practical sessions on MATLAB and one expert lecture also. So we will have you people also can work on your systems. You can bring your laptops tomorrow and then try, and I will show you various MATLAB, how to implement it on MATLAB. So we can work together, and I will also explain to you how you work on it. So tomorrow we'll have more of a practical session, and then tomorrow, day after tomorrow also in Simulink we will be implementing it. Okay, thank you very much, sir. Thank you. Tomorrow we'll meet by 10 o'clock. All of you come by 9:30 so that connections will be done, no problems, and we'll start the session by 10 o'clock itself. Okay, thank you very much.